Good morning, ladies and gentlemen, esteemed guests and everyone. I welcome you all for the Parivahan conference, a ground initiative by IIT Madras students with the aim of promoting and enhancing the Hyperloop technology and creating a collaborative international Hyperloop community. My name is Karthik, I'm a host for your day. I'm thrilled to take you through this event. Before we start this event, I request everybody to raise for National Anthem and Tamil Thai Varthu.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் வதனமென திகழ்வரத கண்டமிதில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு திரை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செய்ய மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
I kindly request everyone to please take your seat. It's time to officially inaugurate our event. I invite our esteemed guests to light the lamp for the beginning of extraordinary journey. I request Professor Kamakoti, Director of IIT Madras, to come to the dais. Mr. Arprit, Team Head, GHC. Professor Satyanarayanan Chakrabarti, Faculty Advisor, founder of ePlane and co-founder of Agnikul, to come to the dais. Mr. Rajesh Kumar Jain, Principal Executive Director, Electrical at RDSO, under the Ministry of Railway, the Government of India. Mr. VP Singh, Additional Member of Railway Board. Please come to the dais. exchange papers.
Friends, students and young children, a very, very hearty welcome to the IIT Madras campus, IIT Madras Research Park. This is again one of the many days at IIT Madras in the last year have been a defining moment for our institute. And today is yet another day where we are embarking on a very important journey, specifically in the area of next generation transportation. Hyperloop has been a topic of discussion, topic of research, topic where many innovations have started across the globe. But we are very happy that in India, in our country, we at IIT Madras, with the support of more than 12 dozens of students over the last 3 years, and with the good, great guidance of many of our faculty and many of our investors and the Ministry of Railways, together we have now achieved something that we can really be proud of. Friends, it's just an inauguration, a long, long journey to go. But this journey today actually starts in a very grand gala way. Why I say it's grand gala? Because, number one, we'll be setting up a 492-meter test track for Hyperloop in our Tayur campus. And this will be the longest test track in Asia, if not the globe. And we will be conducting multiple competitions in the area of Hyperloop. Plus, we will also be giving that as a very, very important test bed for all researchers, all startup companies, and all industry who want to experiment their Hyperloop-related technologies towards commercialization. I think that's a very, very big contribution that we, as an institute, IIT Madras, does for this country and also for the globe. We believe that this journey is going to be a very technically rewarding one and a commercially productive one and also a globally useful one. We really want, with the Sustainable Development Goal and the commitment of the globe in its total entirety regarding energy conservation, we strongly believe that this particular project, the Hyperloop, will be the answer to how we reduce energy consumption, specifically in the area of transportation. We have a lot of very important goals to achieve. I wish the team all the success, and I also very strongly believe that the company tutor that has come out of this particular venture must grow. All our students who are involved there, must continue in tutor as an employee. I have also a dream for IIT Madras, which I keep repeating in every meeting. And I also strongly believe if I keep repeating in at least 100 meetings, it will become true. Friends, this year, we had a target of 366 patents in the previous financial year in terms of filing, a patent a day scheme. And this we have been echoing for the last 3 years. This year, I'm very happy to tell you, we have breached for the first time in the history of IIT Madras and probably any academic institution in the country. We have filed close to 400 plus IPs. And we also have 400 plus IPs granted this year. So that also is a double dhamaka that we got. So I am now started repeating this and will continue to repeat, and I strongly believe that it will become true. When our placement starts on December 1, 2025, next to next year placement, I'm requesting all my kids to give the director the pride of announcing that 20% of my graduating class are already CTOs. That's the way we need to grow entrepreneurship in our country as we move towards 2047, the Viksit Bharat that we are talking of, our Honorable Prime Minister's view and his vision. I'm sure we should become employers rather than employees. IIT Madras students should give jobs, not seek jobs. And this is my view, and this will be the legitimate pride of our institute. And this Hyperloop must set a very big trend for that. I wish all the best for all the young kids who have put this program together. It's a very humble beginning. Again, I repeat that we will celebrate closure. The first closure for this would be an international competition that we would like to conduct within the next academic year. With all these good intentions, I thank all of you for being here, and also the young KV kids. You're KV or Manavani? KV kids who are all here. I also see some Manavani kids. Yeah, yes, okay. So I'm sure you'll benefit from this. I also want you to think about what you can achieve for the country. Rather than saying that of course you have to clear your examinations and other things. That's how we'll get admissions to your higher studies. But what you need to think at the bottom of the heart is, what is it that you can do to the world at large that will be successful and that will be useful and that will have a great positive impact on the society. The moment you start thinking in this direction and also align it with the Sustainable Development Goals. How many people know about Sustainable Development Goal? Only 2 of you? So go. How many people use Google for searching? All of you use? Just go now after this. Search for Sustainable Development Goals. There are 17 goals set by the United Nations. Please look into it. And if you align all these with your SDGs, I'm sure you will be one of the most very successful. I'm sure Google's Pichai actually studied in Vanavani, right? And I'm sure you will all be as big as him or even better than him. So all the best, and all the best for this event. Looking forward to great outcomes. Thank you very much.
Thank you, sir. Now I welcome Professor Satya Chakravarti, sir, to come on dais to share his insight about the event.
Good morning to all of you. It was actually my duty to give you a welcome address, which means that I should have actually come on stage before Kama, our director. But our director actually had to go for our institute day that's happening at 10 o'clock. So he needs to have that 10 minutes of transit time. And he also saw that our director was actually sort of displaying a lot of servant leadership over there. Trying to get all of us to actually light the lamp before he would do. So he would take the lead on where he needs to, and he would actually push others where he needs to. So that combination is what we really like about him. And that said, so it's now my job to actually welcome all of you to this particular inaugural session. This is a very proud moment for me. I have been the faculty advisor to the Avishkar Hyperloop for nearly about 7 or 8 years now, since about 2017, 2018 timeframe. As I always keep saying, I'm the oldest member of the team, not by age, but by the longevity of me lasting in the team. And I have actually been telling, just like how Kama was mentioning, if you keep saying things enough number of times, it eventually happens. Just like how rivers keep flowing past rocks and cleave the rocks away and so on. So with my Avishkar Hyperloop team, which is interestingly a very rolling team, every year we have a fresh set of people. Initially, I was actually pushing them towards thinking about the tube, for example, because the tube was not really part of a competition at the time. And the team essentially was gearing themselves towards a competition all the time. And I felt that the tube was pretty much the elephant in the room as far as Hyperloop is concerned, because it has to actually go on kilometer after kilometer, and unless you're able to bring down the cost of Hyperloop on a per kilometer basis by targeting how the tube should actually be very, very inexpensive, Hyperloop is not going to happen other than just being part of the hype part of it, right? So other than that. So very interestingly, my team actually took upon that piece of advice and started working on the tube, and it's now there for all of us to see. About 300 meters of about 410 initially, and then pushed to 422 in the next few months is actually getting complete thanks to the funding from the railways, a very generous and impromptu support that we have been getting from them. So that's the first step. Subsequently, we have actually been working on a bunch of other cost-cutting ideas. For example, yesterday, the team very proudly demonstrated in the end at night how they are actually doing a hybrid electromagnetic system for levitation that brings down the power consumption from 5 kilowatt per kg to about 0.5 kilowatt, 1/10. That was actually remarkable. We are now beginning to actually look at propulsion from the track as opposed to propulsion from the pod and so on. Lots of such kinds of cost-cutting technologies are being developed to make Hyperloop a reality. One of those such dreams that I had, and I was actually pursuing this with my teams, was the Global Hyperloop competition, which is to basically say, if we are looking at competitions around the world that are not giving you a long enough vacuum tube to test peak speeds, whereas we are actually developing these tubes here, I'm very proud to say that we are the only academic institution in the world to actually have a tube of this kind of length, which augurs very well for us to be able to declare a international competition to happen. So this particular event that we are gathered here today for, that we are inaugurating right now, is to actually announce this competition, which we will do at the 5 p.m. to 6 p.m. Session in the afternoon, evening time frame. And we expect to actually then talk more about the competition itself in the afternoon. I have been given about some 3 or 4 speaking slots in this 2-day event that essentially is going to bore you a lot more. So I'll probably keep my words to something very short at this time, providing a very warm welcome. As my professor's joke goes, Chennai actually offers you a very warm welcome, particularly in the later part of April. So the warmth is actually not missing at all. Most welcome to all of you. Make good use of this particular event, and look forward to a global Hyperloop competition to be announced later today, and walk the entire length of time between now and the competition itself with multiple competing teams around the world, which is expected to happen through this next 6 to 8 months time frame that when the competition is eventually going to happen. So we'll talk a little bit more about that, how we are actually essentially positioning this is not exactly IIT Madras competition, but a more neutral body with SAE India coming in, thanks to them again. So we will talk more about all of those things. So you're trying to position it as if it should be like a very neutral competition, and Avishkar would actually be taking a back seat over there. And Kama mentioned about Tutor. That's actually meant for commercialization of technologies that are getting developed over here. So I'm actually very happy to be in the middle of all of this thing, which is now being characterized as what's called as the IITM Hyperloop sphere, how we are able to actually develop technologies and do POCs, proof of concept demonstrations. We have the ability to do commercialization at a full scale, and we also actually spawn a Hyperloop community around the world with the help of our infrastructure that we are developing through the competition. So these are the 3 angles in which we will be going forward in the future. With these few words, let me stop, and thank you so much for coming here and take on everything that's being offered here. Thank you so much.
Thank you, sir. Now we enter to our event. We have lined up a distinguished technical speakers who will share their expertise on various aspects of Hyperloop technology. Our first topic will be discussed through virtual. I welcome our first speaker, Mr. Dennis Tudor, CEO and co-founder, Swissport Technology.
So you
Good morning, Mr. Dennis.
so you so you
Good morning.
Hello, everybody. Can you hear me?
We can hear you, Mr. Dennis, yes.
Hello. Yeah, thanks a lot. Thanks a lot for the invitation. I'm going to share my screen for a short presentation. I'm extremely happy to be part of this conference. I would like to apologize for not being in person. I had to rush in a kind of emergency way to meet Richard Branson for a meeting and for a panel with him, together with few other people. So I really apologize for not being in Chennai. I would have loved to be there, especially that we had an amazing meeting with you there, and I think the discussions we had with them were literally amazing. So I'm the student and the CEO of Swissport, and I'm going to have a short presentation on our latest advancements and how we can bring Hyperloop for every Indian. So this was in India, and yeah, I mean, please enjoy the short video. So in 2023, we had 3.7 billion passengers that they have been boarded by the global airline industry, which translates in a total 100,000 flights in a single day, which contributes to 4% of global CO2 emissions coming from the aviation sector. That kind of creates an impact of 6.4% on the global warming. And by accessing 10% of the aviation sector, we can actually have an annual drop of 0.7% of the global CO2 emission in the next 10 years and 1.2% of global warming in the next 10 years. Our mission at Swissport is to change the way people and freight are transported nowadays in a better way, in a more cost-effective way, and in a safer way. And we are here as a company to provide a pod solution which is fully self-contained, that requires a minimal investment on the infrastructure. No magnets and no electrification on the rail. We are here to partner up with high-speed rail concessionaires, manufacturers, governors, governments, and operators as well. And our unique selling point at Swissport is to create a technology that can be actually enabled only by the capsule itself, with a fully passive infrastructure. Only kind of common materials can be found in the infrastructure, like steel or like aluminum. We have managed to patent 6 new inventions when it comes to that. Our main invention, it's on the propulsion levitation system with our trapezoidal propulsion levitation machine, which can actually get rid of the end effect. This is a public invention that everybody could see on the public space. We managed to bring up this invention back in 2022, and this has been actually tested in our reduced scale model in Switzerland, as well as is going to be tested at full scale in Colorado, US. So to get to the realization of our product, we have built in Lausanne, Switzerland, the first Hyperloop testing facility in Europe that's been fully funded by the Swiss government. Then we're building the full-scale testing facility in Pueblo, Colorado, with US Army Corps of Engineers. And we're going to create a consortium that brings this solution to the market in new infrastructures, and then we're going to commercialize our capsule solution. This is how it looks like, our testing facility in Lausanne. It has 40 meters in diameter, with half of a meter inner cross section. And we have just recently tested our capsule solution running in vacuum. And I'm going to show you a short video before Christmas how it went. Those have been tests that have been performed during the last couple of months. We have broken the record in Europe for the maximum speed of the propulsion system that achieved 250 kilometers an hour. And we just also broke the record of the longest Hyperloop mission that ever happened in the world. And this is going to be repeated again in the next couple of weeks, and the results are going to be announced soon. However, to get to a product, we had to build a full-scale testing facility, which is going to be around 1 mile. This is going to be the only Hyperloop testing facility which is placed in the United States of America, and we're actually working very closely with US Army Corps of Engineers and MXV Rail. This is going to be built in phases. It's going to be a real loop system where we can actually benchmark our product for high speeds and long distances. We do believe that the main challenges of Hyperloop are coming at high speeds and long distances, and tests that are going to be relevant are going to be performed in more than, let's say, 50, 60 kilometers as a trajectory. Just few pictures that we've gotten at the beginning of the construction with our employees and contractors in Colorado. The first 300 feet that have been actually built already, and we're going to continue the production of the tubes as we actually did in the last couple of months. And this is going to be probably finished in the next 1.5 years. The whole testing facility is going to represent one of the largest vacuum chambers in the United States of America. We think, and based on our calculations and numbers, the cost for a Hyperloop system using our capsule solution is going to be between 25 and 35 million a kilometer for passenger transportation, while for freight transportation is going to be between 12 and 18 million US dollars a kilometer, with an energy consumption, average energy consumption cost of around 60 watt-hour per passenger per kilometer for speeds of 500 kilometers an hour. Our vision for India is to make the high-speed transportation system affordable for every Indian citizen, in the same time where the government can receive the return of investment in around 10 to 12 years. We're super proud of our memorandum of understanding we signed with Twitter 1 month ago. This has been actually signed together with the CEO of Railway Board and with our Swiss ambassador to India. The Swiss president has been informed about our collaboration, and we have already started our internal discussions with the Swiss government to co-found an infrastructure route that will run commercially in India. The discussions have been started already with the State Secretary for Economic Affairs. We have put an amazing team together. We have Cyril, which is our CTO and has been running the whole operation in Switzerland together with EPFL. And Dario, that has been actually running the whole operations in the United States. And Gila, our member for safety regulations and standards. The board is pretty Dr. Satiris Bagdadis, together with Professor Mark Gruber, that has been the innovation of EPFL in bringing startups to public markets, and Robert Karsunki, that is our CFO and the Vice Chairman of Finance. He was actually the CFO of Novartis Global, and he has been our first investor. Partners are quite a lot. We've put a lot of partners in place, especially in Switzerland, in the research and academia partners with CERN, EPFL, and MXV Rail, with the US Army, with Swiss government. And yeah, thanks a lot for your attention. I'm not sure if it's there is any. There is any. I'm pretty glad for being part of this conference, and I'm pretty sure that we're going to do an amazing work together with the Twitter team. So thanks a lot.
Thank you, Mr. Dennis. Thank you. Now I welcome our next speaker, Mr. Gabriel Simon, Project Lead, TEM Research and Development Program at Technical University of Munich. Mr. Gabriel will enlighten us on the building a passenger Hyperloop, offering a valuable insight into this revolutionary mode of travel. Please, sir.
Thank you very much. Have downloaded it? Okay. So this is, yes, all right. Okay, then, thank you very much again for the invitation. I want to thank all the people involved in the organization, both the faculty and obviously the students, for organizing this and for having us here today. My name, as was mentioned, is Gabriele Semino. I'm the project lead of the Hyperloop Research and Development Program in Munich at the Technical University there. And as we'll see in a moment, what we have focused on the Hyperloop side is mainly the passenger component of it and trying to start testing at the scale that we will need for passengers. So what I'll try to do today is give you a little bit of a perspective on Hyperloop from the side of a European research program, but also on the side of building something that is sized for passenger transport. So maybe with the very general point about why we believe that Hyperloop is needed as a solution. I think the thing that is often discussed is obviously speed. We need a system that has higher speed, considerably higher speed than rail, just to compete properly with airplanes on longer distance travel. For us in Europe, it means connecting more across borders. Generally, railway systems are thought for single countries, which are quite small in Europe, but still railways were thought for each country by itself, and now having a system that can actually connect Europe all together and compete properly with an airplane, which I think is then very similar to what you would also want to have in India. Obviously, one thing with high speed, in particular in densely populated areas, which is something that we have in Europe, is that we also have to focus on making sure that we allow direct connections. If a train has to stop at all the stops, and we want to get rid of that by having small vehicles and connecting cities directly. I think I'm not saying nothing new for this audience, but these slides are also generally for when people don't necessarily know about Hyperloop. And I think, obviously, the main component and also the main driver for Hyperloop realization is cutting down on emissions, mainly caused by aviation, but also by road transport, by bringing those people into a mass transportation system. Now, with this goal in mind, the question is, why are we working on it in Munich? How did it came to happen? And actually, the way it came to happen is very similar to what happened here, in the sense that we first started when we were taking part in the SpaceX Hyperloop pod competition. So that's actually how I got started. If you look at the guy here on the left, that's a very young version of myself. Well, it's not that many years ago, but still. Back then, the team was really founded, as many of the Hyperloop initiatives around the world, driven by the SpaceX Hyperloop pod competition. Back then, roughly 30 students came together each year to build Hyperloop prototypes. And I think this story we've seen here, we've seen in the Netherlands, we've seen all around the world. And that's why I think I want to stress, I think it's a very good idea to organize a competition. I think this is the right way to go to motivate more and more people to get into this industry and push innovation forward. And so, yeah, we took part in the SpaceX competition several times, actually. In 4 out of 4 competition, we had the fastest vehicle. Wait. Let's see, there it goes. Yes. So yeah, we started in 2015, 2016, building small prototypes for the SpaceX Hyperloop pod competition. In 4 competitions, we had the fastest pod, which was the main goal of the competition at the time, building a fast vehicle. And then this, in principle, built enough momentum in Munich to then convince the university and the local government, in particular, to fund a research program to focus on a passenger system. And so this was really what we chose to go for, is not necessarily the length of the track in the first step, but the size of the track. I think several other teams are testing longer tracks, and I think it's very important. But we wanted to give you a picture, and also do research in the right size. So what we did in principle is, if you think about the long Hyperloop tube that will one day connect cities, we'll try again the animation, let's see. There you go. So in principle, we took one segment and built that segment in full scale. Now, you don't necessarily see it from this picture, but this picture with the guy in the front is not particularly small. It's just that the tube is 4 meters in diameter, and it's actually full scale. What I mean by full scale, by the way, so the way we sized this is that the passenger cabin is such that you can stand inside. Even a big German man should be able to stay inside. So I think it's 2 meters at the highest point in the middle of the aisle. And it's a 2.5 meter diameter pod. So it's a 4 meter diameter tube. Which in principle is the size of some regional aircraft. So it's something that's already operational and long-term allows for a 2+1 configuration easily. So this is kind of the size we chose for that. The tube is 24 meters long, so relatively short for that, but still, as I mentioned, our goal was to focus on the passenger aspect of this and the passenger size. Maybe to go a little bit more deeper on what we wanted to test with this, I will go into a little bit more, not too much, but a little bit more technical details later. But the goal was to test critical subsystems for the Hyperloop, also integrate them into one system, coherent system, and build this in passenger size. And one very important aspect that was already mentioned a couple of times also yesterday is safety. If we want to transport passengers, we have to focus on safety. And so we put a lot of effort in try to think about safety as much as possible from the beginning. So what we've done indeed is there is obviously around the world there is still no official Hyperloop safety guideline that we can use. But there is a German organization called TÜV Süd, which is a safety agency around the world that in principle generally has the task to enforce existing governmental guidelines. But what they did is a study based on other guidelines from airplanes, trains, and so on, and they compiled a list of guidelines to be used for Hyperloop as leads as an intermediate. And they had already these guidelines set up when we approached them, and in principle what they did is they applied this guideline for this and then certified our test track for passenger operations so that our engineers didn't just build something, but they had a third party checking over them so that we were sure that the passenger side of it was also being done properly. And personally, I think that was quite important because the goal was to do this. In principle, myself and a colleague sat in the pod in vacuum, which was done kind of for the first time in Europe to actually have people in a Hyperloop pod in vacuum. And since I had to sit in there myself, I was quite interested in the safety aspect of it being taken care of properly. And I have a short video. I think some people have seen it already. I was mentioning a couple of times yesterday. But as a short video about our project, in particular about the passenger run, to give you also an idea about our test track. And also, as you will see, the large amount of students that were involved in making this possible. Maybe. Could it be still loading? That's the 9th slide, yes. Next slide. Yeah. I think the video is still loading. Maybe we'll try that later. So in principle, if you look up the video on YouTube, maybe later on, the test track that we built allowed, as you saw, the pod being rolled to the test track, and then we put him in the test track, and then a passenger were loaded in. We had a pump down phase, and then we performed a drive in a vacuum, which in principle, from a technical point of view, tests the exact same things if there are no passenger in there. But obviously, the demonstration purpose is to give people an idea, and also to kind of give people the feeling that the people working on Hyperloop are actually taking safety seriously, so we'll sit in there as well. Maybe to go a little bit more into the technical aspects of what we wanted to test here, and also a little bit of the design choices that we've made when it came to the test track. We had very interesting discussions also yesterday, and I think more to come about how to build Hyperloop, how to build it effectively, how to build it cheaply, and what technologies to go for. One thing that when we started was less common than what I've heard is today several times, is to look at a tube made out of concrete. What we looked for in concrete is, well, first of all, Germany has a lot of tradition in building maglev trains, and we developed the maglev trains that then the new government decided not to build. That's a different story. But in principle, the development of maglev trains showed us that for maglev trains, concrete is a good material for the guideway, in particular due to its properties. But also in general, concrete is a relatively cheap material when produced on a large scale, and it's very good for durable infrastructure. But obviously, it's not the first choice when you think of a vacuum tube, just because steel can be welded. Steel is definitely easier to make it into a vacuum tube. And so what we wanted to demonstrate here is one configuration of a concrete tube that is made out of segments that are then pre-stressed together to achieve that we can only put the tube, like hold the tube at the front and the back. So we have a bridge and a tunnel in one that is also a vacuum tube and definitely performed quite well when it comes to being tight for airtight, for vacuum. I think still some optimization can be made and some improvement can be made, both to make the tube lighter and cheaper to build, but also to make it better for vacuum compatibility. But in principle, it works, and the wall is airtight. The challenge is making the connections between the different segments tighter and tighter over time. Here I have some pictures about the manufacturing. The concrete tube was made in a specialized facility like the single segments that generally does wind towers. So in Germany there is this industry of doing wind towers by concrete segments put on top of each other. And in principle what we have is a wind tower laying on its side. And so the modules were pre-casted and then brought to location and assembled. I think the video is loading again, but in principle they was then placed into location with a crane and the single, and as you can see, they're comprised of two segments. One is of two elements. One is the outer ring, the tube, and the guideway on the inside, where then all the rails were installed. This is then how it looks when it's done. So this is inside, looking inside of the tube on the right side with the pod. As you can see, everything looks quite big. It is quite big. And the good thing is that you can really walk in and then walk into the pod and actually get a feeling of how big Hyperloop needs to be to transport people. On the left side, you see a small part of the vacuum system that actually allows you to pull a vacuum. When it comes to levitation, I probably don't need to explain electromagnetic suspension to this audience, but in principle, the design choice that we made back then, not knowing, for instance, that Avishkar made the same design decisions, is that the pod is inside the guideway, and on the two sides there are steel rails so that the pod can attract itself to the top. Apparently a good choice from what I've heard yesterday, and this in principle allows us to levitate quite efficiently with electromagnetic suspension, and also you have the same system on the side for guidance, and the whole thing then looks like this. If you build in hardware, you have this module below the rail. When it comes to the motor, maybe here, this is I know, a highly debated topic. What we chose is a linear synchronous motor based on an excitation system in the pod, which in principle is just a permanent magnet, and a track laid down on the track. This is something that definitely proved to be a possible configuration that we're, however, looking strongly into whether it's the most suitable configuration going forward, in particular because the motor is in this configuration only on the track side, so it would probably have to be built along the whole track, and maybe there is better and cheaper alternatives in the long run. However, we do think that a track-based system, at least for part of the track, will be necessary for adding the huge amount of energy that you need to accelerate the pod to very high speeds. One additional, this is also a picture of how it looks. So in principle, in the middle of the rail, below the pod, you can see the linear induction, linear synchronous motor that you can also see on the left side a little bit more in detail. Maybe one final thing that we added onto the pod, since we're already building in passenger size, and this is not very typical for a research program to do this thing, but in principle what we wanted to do is not only build a technology demonstrator, but also give the people some picture, ideally a good picture of how traveling with Hyperloop would look like. So we collaborated with another German university that has specialty in design and interior design and product design, and so we developed an interior concept for Hyperloop. And but we didn't just want to show nice pictures, but this is actually a picture of how it looks inside. So we actually also built the interior of the pod to really try to be as close as we possibly can on a demonstrator already to a Hyperloop system. And also because we really do think that it's important that Hyperloop is not just discussed already in a Hyperloop enthusiasts group, but it's also brought outside to the general public for them to give an idea and for them to give a picture of how Hyperloop could look like. So what we did, for instance, is we showcased at one of the big European events on mobility, the IAA Mobility, originally a car-only event, but now moving towards mobility, which happens to be in Munich, so it was quite easy. In the Munich city center, we showcased the pod, and we had over 5,000 people get into the pod over the course of the week for people to ask questions, see what Hyperloop could look like, see what the good work that's being done by us and by the Hyperloop community, and get them involved. And for those of you that will attend the European Hyperloop Week later this year, we are planning to bring the pod there, so you will also have a chance to sit inside. Maybe one final thing, and again, stressing the point about not just talking about Hyperloop, but actually building Hyperloop, and I think you're proving this also here in what we're doing. I think this is the slide I wanted to show. This is the rendering we have been showing for a while once we were planning the whole thing, and then when we had our groundbreaking in September 22, in principle people asked, well, this is just a rendering, you'll never build that, and this is how it looked 9 months later. So in principle, really making the renderings we show about Hyperloop, we should now build in reality and prove to people that it can be done, it can be built. And I think what is happening all around the world is that now in many places actually building hardware and giving people a picture of what Hyperloop looked like. Maybe one final point from our side, how we want to proceed going forward, and this is more like the outlook and our ambition going forward, but we do think that for keep going in the Hyperloop development, obviously our first segments at relatively low speed is not the final endpoint, but we will need longer test tracks to test our technologies, to keep going on the passenger aspects of it, keeping safety at the center of it, and making sure that we think of Hyperloop, about the passenger all the time while we develop Hyperloop. So this would be a longer test track, roughly 1 kilometer in length, that we are currently in the process of conceptualizing and starting the planning to actually think about passenger operation, where people not just test pilots as it was for the demonstration, but actually any guest is then allowed to come and drive with the Hyperloop on this test facility. On the passenger side, but on the technical side actually allows us to test missing components that the demonstrator obviously didn't have, like switches and curves and airlocks and so on, that are definitely needed, and think about how to scale them and have them work properly on the long run. So this has been from my side. Thank you very much again for giving me the chance to be here to present a bit of what we have done. I'm looking forward to the discussion later on. If you have any questions, come to me or reach out. Here, our website and our email address. Happy to answer any of your questions, and really looking forward to what all the young engineers or the young students here will be able to do for Hyperloop in the next years. Thank you very much.
Thank you, Mr. Gabriel. Now I welcome Mr. Osama Amin, Senior Research Scientist with CEMSC Division, King Abdullah University of Science and Technology, to come to the dais. Mr. Osama will share his insight on paving the way of reliable Hyperloop communication system through intelligent surface. On to you, sir.
Thank you so much for this kind invitation. It's my pleasure to come and present my work here. Thank you so much also for the hospitality. This is like kind of first presentation for myself and for this conference regarding the wireless communication solutions. So this is an important piece of puzzle for the Hyperloop. For this purpose, I will try to make it very simple in a kind of tutorial way, and so that everyone can understand, and we can have a discussion after the presentation. Is it ready? This one. Okay. Okay. Let me start first by asking, what does communication means? So communication, it's like exchanging information. Okay. How we can exchange information? Simply If we are talking in front of each other, we can talk. What will happen if we are far? Okay, so if we are far, we need to look for a carrier that transfer our information. In the past, people used the smoke as the first carrier. Okay, things now we have now the radio frequency as a carrier. We have the optical signal as a carrier. We have molecular particles as a carrier. So this is the concept of communication. Okay, I divided this talk into 3 parts. First part is related to the challenges of Hyperloop communications. Then I will delve into a proposed solution and what we can do for the future. To understand the challenges of Hyperloop communication, let us start the journey of railway communications. What happened in the past? If we start from the pre and early 20th century, in the pre, actually, we didn't have any communication systems, so the people used simple visual signals, flags. Maybe then, this is for coordinating between the trains. After that, also, in the same time, okay, with the development, they used the telegraph, that. So they converted the communication into codes of dots and on and off codes. When we have the communication system developed and we have analog communication, they start working with analog signals in the mid of 20th. We had voice communication between train and control stations and centers. Later on, late 20th century, we started working with the global system for mobile communication. By the way, usually in communication systems, it takes a decade, which is 10 years, to cook a generation. Okay, so the moving from first generation to second generation, 80, 90, 90, 20, to 2000, 2010, 20. So by 2030, we should start 2030 should start with the 6th generation. And for each generation, we will have a kind of railway version of it. So the 3rd generation, GSMR, it was robust, secure, and it provided voice. But however, it's a very limited data rate. If we're looking for data, we have kind of 9 kilobit per second. The latest version, which is the long-term evolution railways, this is related to the 4G. It is defined in 2008, and it's expected to be completely operational soon, next few years. We can have here real-time video. We can have high data rate. Okay. To understand more about the latest technology, let us focus on the last 2, GSMR and LTR, long-term evolution railways. I will focus on these 2, explain some characteristics. This will help me also to explain some terms in communication. The carrier here is the radio frequency carrier. Okay. The radio frequency carrier has a frequency and has a bandwidth. This bandwidth, it means the amount of changing in the frequency. For the GSMR, we have 2 links, uplink and downlink, because we have 2-way communications. 885 to 889, this is for the uplink, and for the downlink, we have 93 to 9334. The bandwidth is 0.2 megahertz. The bandwidth tells us how much information we can transfer. So this means if we want to add more information, we need to push the carrier frequency. However, nothing comes for free. Pushing the carrier frequency results in attenuation in the signal, which means less coverage. So this is like a general rule in communication systems. So keep this in mind, like while we moving forward to LTE and 5G and whatever. So to improve the performance, the LTR pushed the carrier into 1.8 megahertz, and also they have different carriers, as we see. And pushing the frequency allow us to increase the bandwidth. We can see we have here 1.4 to 20 megahertz. So this allows us to transfer more data. Okay, this is good. The question, can we support mobility? So this is one of the challenging questions. When we move, the communication channel changes. So the problem happens if the channel changes more fast than the signal. In this case, we'll not be able to detect our signal. And we will have something called the Doppler effect. So what is the Doppler effect? That's why I preferred the PDF. Unfortunately, okay, let me tell you what you can see in these figures. When I transfer a sine wave, a signal, okay, and I have a train is moving towards me, what happens? This sine wave, I will receive it compressed. Okay, this is the figure which I cannot see. And if the train moving far away from me, the sine wave will be expanded. Okay. So expansion in time means low frequency. Compression means high frequency. Okay, so this is the Doppler effect. We are afraid that the channel change will be faster than the information. To know this critical parameter, this is the equation. What is the equation? Okay, we have it, good. So this equation can tell you if this technology can support this speed or not. Of course, more details, you can find it in this reference. We developed the first Hyperloop survey for the communication systems. It's open access paper in the IEEE community. So here we can test the latest technology, which is the LTR. This equation tells us about the maximum speed that system can support in kilometers per hour. We have here the carrier frequency, the maximum carrier frequency, which is 1.8 megahertz, and the simple duration. So if you use the parameters of the LTE, it seems that this is the maximum speed that we can support. However, take care. This is the maximum speed does not mean that you are working in the full capacity of the data rate. It means like you have very low data rate. Okay. So this means that current technologies cannot support the Hyperloop from the Doppler perspective, Doppler effect perspective. Another thing that we should consider, usually any base station, it covers a range. We call it the cell range. And if we have high-speed train, moving between the cells will be very fast. This means that we need to connect the train to the new base station in a very short time. So this is another critical parameter, and we call it handover rate. So this is another challenge. For very fast transportation, we need to disconnect from a cell and connect to another cell in a very short time. So Doppler effect and handover rate is like two challenges. So this means that current systems cannot support the Hyperloop because of the Doppler effect and the very fast switching. Okay, so this is a summary. Current technology cannot support Hyperloop because of the severe Doppler shift, severe handover rates, This is the parameters which I discussed earlier. Another thing, we have isolated environment. So this is steel environment. If it is steel, then signal cannot come inside. It will be reflected. And if we have a concrete, very small part of the signal will come inside. And in case of the steel, if we injected a signal inside the tube, the signal will bounce and will have lots of reflections. So this means that we'll have lots of multipaths. You receive it because it will not come out. It is closed. And in electrical engineering, we call it waveguide. So the signal will keep bouncing, going until it completely absorbed. So this means that you will have thousands of of the signal, reflected signals. So we have a highly scattering environment. And also we have very strict quality of service. Safety is very important. We need to know all information about the inside pods. So all these challenges cannot allow the current high-speed railway technologies to operate in Hyperloop. Before looking for solutions, let us have a vision about the taxonomy of Hyperloop communications. Why we need communications and what are the players? So this is like what we provided in our survey. First, regarding the technology, these are candidate technologies: long-term evolution, railway, 5G. This is the current technology. Wi-Fi. If we push the frequency more, we'll go to the millimeter wave. Millimeter wave, the frequency is from from 40 and up, 40 gigahertz. By the way, the maglev train, the Shanghai one, it uses the millimeter wave and it uses the 70 gigahertz. So they pushed the carrier to have more bandwidth and to mitigate the Doppler effect. So I just want to mention something. Two things play with the Doppler effect: the bandwidth of the signal and the carrier. You need to design them carefully. Going back, so another candidate player is the free space optical. We can have laser inside. Okay, of course, but this one needs to be designed carefully. Another point which is important: how we manage our resources. Okay, this the power needed for communication, the power needed for the pod. Okay, the communication will play also a role in this. The equipment, the staff assignment. The communication also, one aspect of the communication is the networking. Networking includes devices, infrastructure, optical wired through optical fibers, wireless sensor networks, and protocols. Another also player is the devices, as I mentioned. We can have like different types of sensors and device management through barcodes or QR codes. One important aspect is the cybersecurity. We need to maintain our system privacy, secured as much as we can. We need to make it immune against cyber attacks. We should also remember the most important thing, which is the safety and emergency handling. We should put plans for natural catastrophic cases. That's why we should have like alternative communication solutions, and also emergency evacuation, terrorist attacks. Regarding the service, we need to provide the communication between the tube and the pod and the passengers, the train operational control. We need also to provide the passengers with information. So these are the types of services. So we need to keep this in mind, like to motivate for developing communication system and also to design communication solutions. Let me define here the research directions in Hyperloop communication before I show you what is the suggested system that can work. Before defining the research direction, okay, this is the communication network. It consists of a core network where all network providers are connected. For example, here in India, you have different cellular network providers. They are connected in the core network, and if you have satellite services, also they are connected in the core network. The connection usually is like via optical fiber, because this is the fastest mean. We have then aggregate network. Okay, the aggregate network organize the packets and like distribute them between different users. This aggregate network is connected via Ethernet or optical fiber. After that, we'll go to the control center and cellular networks, where we connect with the radio access points. One of the radio access points will feed the Hyperloop. Okay? So this tells us that we need to think about the network architecture. This is one aspect for the design. Okay, we need to think about the radio access, which is the cellular planning the cells, how we are going to plan the cells. We'll have like a moving cell or fixed cell or mixed between these cells. So this is another direction, important direction. Third direction is the antenna design. So the antenna design, how we are going to design our antenna. This is one aspect. And the software development. Usually, the network now is controlled and programmed by the software, so that we have something called software network design or control. So these are the four aspects. In the following slides, I'm going to propose like a solution. This solution will capture radio access and network and antenna at the same time. This solution will be based on something called intelligent reflecting surfaces. Okay, what is intelligent reflecting surfaces? This is something new which has been proposed last 10 years. In 2012, they find a way to control something in one parameter called mu in the materials. After that, as a result, they succeeded to control the material characteristics using the electrical field. So as a result, in 2018, they produced one cell intelligent reflecting surface, which does not consume power, but is able to reflect the radio frequency signal and focus it in a desired direction, which means that if we are in a place that doesn't have a cellular coverage, we can use this intelligent reflecting surface and adjust its phases. It will guide the radio frequency carrier and direct it into uncovered area. Nowadays, the IRS is under development, and there are lots of test beds in different universities at different bands, and are doing lots of experiments. So we built our solution based on the IRS. So again, it is a passive. It can be passive or active, but like we are interested in passive since it does not consume energy. It just guides the signal. Okay? And what it can do beam steering. Let me go through the solution. So this is the intelligent reflecting surface as tested communication system. The idea is to avoid the multipath. As I told you before, if we inject a signal inside the tube, it will be reflected, and we have lots of versions, and we have lots of interference. Okay, so how can we avoid this? Okay, let us allow the signal to track the pod. Of course, we cannot do this mechanically. The only way to do it is electrically. So we can use this intelligent reflecting surface, which can direct the signal by changing its phase electrically. So here we have 2 players. We will put antenna inside. It can be a planar antenna, but just like this is just for illustration. Okay, and it will direct a beam towards the intelligent reflecting surface. The phase of the intelligent reflected surface will be changed with time in a way that it will track the pod. So it will, and also the beam will be focused. So this means that the beam, the beam illumination area should be within the receiving antenna. So this will prevent having multiple reflecting signals. So the signal, we can here track the pod with the signal, thanks to the RIS, which focus, as I mentioned, focus the beam. So now, I showed you before like the cell. Now the cell is inside the pod, okay? Because like, as I told you, like getting the signal from outside to inside is not easy. So we have like a cell inside the pod. What is the size of this cell? How many cells do we need? This is another challenge. Let us discuss this point. So if you can see the graph in the middle, this is a cross-section view. We have the transmit antenna. So the transmit antenna sends the signal to the IRS, Intelligent Reflecting Surfaces, which reflected the signal and focus it into the pod. The IRS, it do electrical scanning to track the pod. So it has like this, the graph in the left, it has this theta parameter, okay? So I mentioned this because like it has something related to the in-pod design. We propose like tilting this surface so that we can extend the coverage, okay? This will allow us to use less number of cells and like save the cost. Like more analysis can be found in this paper. Okay, so I'm just telling this because like this is one of the constraints of the design. If I like to include this setup, okay, we need to have this IRS, which is fixed under the tube with this distance h and tilted with an angle theta t. Let's see the transmission and reception scenario. Any antenna, it has like a pattern, radiation pattern. This is the radiation pattern of the antenna. So we should have like a directional antenna that sends its signal, and it should be captured completely by the IRS, okay? Then the IRS will reflect the signal, as I told you, to track the pod. What about the receiver? I told you before that the antenna, it has a direction. So that's why here, the receiving antenna at the pod, it should be from the type which is we called sectorized antenna, which means that it can receive signals from different directions. This will allow the signal to be captured for long distance, okay? So this is the type of the suggested receiving antenna. Here I'm summarizing the design aspect of the IRS. First, we need to design the tilted angle while considering the physical dimension constraints of the tube. We need to have this multi-sector receiving antenna to allow receiving the signal across different locations. And also, as I told you, we use the electrical switching mechanism. However, the switching time is not zero. It's very small, so we need to consider it. So the efficiency will be like a kind that the time used for transmission the data divided by the total time. So this switching time, like it changes with while we advance in the technology. Now it's, I think it's the nanosecond scale. And another aspect that we should consider is the illumination area, which means the spot of the signal after the reflected signal on the receiving antenna. As I mentioned, the receiving antenna should capture the whole reflected signal such that we avoid the reflections. Regarding the Doppler effect, just remember the first equation. We need to consider suitable carrier, suitable bandwidth. Okay? As like Shanghai train moved to the millimeter wave, similar to this. Okay, let me just summarize the merits. Here, the challenge and the merit that we introduced by our solution. We have isolated environment if we are going to use the steel tube. Okay. Now we're putting cells inside the tube, so we have multiple intelligent reflecting surface working as an access point to provide a network, and we tilt it so that we have extended coverage. So we mitigate the highly scattering environment by using intelligent reflecting surface, which do a kind of beam steering the signal towards the moving bot. So and as I told you, we overcome the limited cell coverage by using the tilted IRS, but however, we need to consider this from a design perspective when we build the Hyperloop. What we did, I'll mention this quickly. For the design problem, we have two parameters to design. We need to design the position, and we need to design the phase shift of the IRS. The position is done by one time. Okay. However, the phase shifts is done like is a time varying design, and it changes with the time according to the speed. And this can be done by a microcontroller. Another thing to design, if you recall, I told you about something about the handover rate, which is the rate we switch between each cell and the other cell. So these cells should be overlapped so that we can guarantee a smooth signal while moving. So here, to design the multi-cell inside the tube, we design this overlap between both cells. And also this has been done by different optimization methods. Let us have an idea about the cells inside this tube. What is the range, for example? The one in the left here, it tells us about the range, okay, for different abilities of the IRS. IRS is doing a scan, okay. This scan, it can be like small or big. So this is for different values, 15 angle and 55. Anyway, it seems this range is like around 110. So we can see here, because like we have limited area, limited volume, we have very small cell. The cell usually like in kind of 2 kilometers or 1 kilometer. Now we are working with meters. Okay, so this shall increase the cost, of course. That's why we propose using IRS, because like it's a kind of passive element. It can be passive or it can be active, but we propose using IRS because the passive one, which does not consume energy. The second plot, actually, it has a nice story. When we sent our work for review, we received a comment. Please compare your work with any existing system. However, we don't have any existing system. how can we compare our work with the existing system? So what I suggested, okay, I told the student, okay, let us compare our system with an access point, like access point inside any antenna point inside any like Wi-Fi module working in the same band. And we are going to assume that this access point, of course, it cannot track the system, but it has like whole coverage. It covers the whole tube. It's an imaginary system. And we'll be able, by a genie way, to remove this interference. Unfortunately, we achieved better performance. Why? Because we focus the power. The second system does not focus the power. We focus the power in a single beam. So we took the full advantage. The graph in the right, it tells us about the impact of the rate versus the overlap distance. And the right part of it, it tells us about the handover rate. So the blue one is the rate versus the overlap distance. The cells, we mentioned like it is 110 distance. So if they are covered, if they overlapped by 10 meters, we'll have this amount of rate. When we increase the overlap, we have more rates. Of course, like we have like extra reliable system. However, what happens? The handover rate increases. This means that we are going to have more access points and the cost will increase. So we should have we should consider this carefully while designing. The figure in the left gives us idea about how many cells do we need with the distance. For example, if we have 1 kilometer based on our proposed system, we need around 18 cells. Okay, so like this is for different overlap regions. We can see like if we increase the overlap to 30 meters, the number of the cells increases also. So there is a trade-off between the performance and the cost that should be considered in a wise way. So this solution, like we studied theoretically, but based on practical test bits that is available. IRS is not available commercially, but however, it's going to be available commercially. We have it in the labs. Okay, so we used real values. Okay, so if you like to test the system, we can build it based on the existing test bits. But it's expected that IRS will be in the market very soon. Third part. Okay, now we proposed a solution. What about, can we improve this solution more? Yeah, this is some future research aspects for Hyperloop communications. Remember, I told you before that mitigating the Doppler effect can be done by increasing the frequency and considering suitable bandwidth. Just remember the equation that I showed you before, and also the cases which has been done by the Shanghai train, where they used the millimeter wave, 70 gigahertz, for their train, which runs with 400 kilometers per hour. Okay, so what can we do more in the future? We can push the frequency more. What's after the millimeter wave? Millimeter wave ends around 90 gigahertz. Then the terahertz band starts from 100 gigahertz and up till 10 terahertz. This band, it has a rich bandwidth, and we proposed like a visionary study for the 6G, which is the next generation communication network. And it has been published in Nature Electronics. And we propose using the terahertz band for the coming 6G. However, what is the problem in this band? This band has a severe problem. Remember that I told you before that when you increase the frequency, the coverage decreases. So this means that we cannot send the signal for long distance. This is first problem. Second problem, that for the terahertz and also for the millimeter wave also, the signal suffers from absorption, molecular absorption. The vapor absorbs the signal. So it is attenuated significantly. The graph in the left here, it shows us the path loss, which it's an indicator for the signal attenuation versus the frequency. This is the part of the terahertz band, not the whole terahertz band. The terahertz band ends at 10 terahertz. Okay, and we can have here severe attenuation because of the vapor molecular absorption. However, remember that the Hyperloop environment is a vacuum, right? We don't have any water molecules. So this is a benefit, actually. So you do this, guys, like to reduce the friction and allow high speed. This also helps the communication. We can achieve higher data rate, and the attenuation can go very low. If you can check the right-hand side graph, this is the effect of air evacuation. The path loss goes down to 100 decibel instead of these very high peaks. So here we utilized one of the aspects of the Hyperloop, and we propose using the terahertz band for communication. This will allow for very high data rates and improved communication solution. Of course, this will be in the future because, like to be honest, developing transceivers in the terahertz band is also challenging, and it's under. We have some. I mean, over the world, there are some experiments, some test beds, but like this is one of the challenging aspects. So, but anyway, this is one potential solution for the future Hyperloop communication solutions. One benefit of the terahertz bands, it has like a pencil beam, which is very good for communication, because like when you have a pencil beam, we can avoid the multipath reflection signals and we can reduce the interference. It's a disadvantage of the short range. It should be fine since our cell is small, 100 meter or 200 meters, it's okay. We'll not have a problem because of the short range. That's why terahertz is a good fit for this application. Finally here, this is another architecture that we propose. We can use different tilted IRS, but also I'd like to tell you about recently something called large intelligent surfaces. It is like the reflecting surface, but after providing it with radio frequency chain, we'll have like a kind of antenna, and very large antenna that can generate steered beam in an efficient way. Also, this is one of the very new technologies.
Why I love Envato Element?
That we expect that it will be maybe in the market after the IRS. So we propose this using so that we can have uplink solution and downlink solution. Okay. By doing so, like we can avoid the multipath. So this architecture, the architecture avoids the multipath reflections. Going up in the frequency, we can avoid the Doppler effect. So this is like examples of the future work. Let me just conclude the talk. Let me give you some quick messages. Here, one of the promising solution is considering intelligent reflecting surface, whether it is antenna or intelligent reflecting surface inside the tube. This will allow us to track the bot and by beam steering the bot and avoid the multipath signals and reflections. To avoid Doppler, careful design of carrier frequency, and the data rate can avoid this. This can be done by going to the millimeter wave and terahertz bands. And also don't forget optical wireless communication is also another candidate. Terahertz band also one of the candidates that can fit well. Something that I didn't mention here, but you can keep it in mind because it's coming very soon. There's something called OTPS, orthogonal time frequency space. They are now developing this system, and the standard should be ready, and it will come very short as an IEEE standard. It can also mitigate the Doppler. To make it very simple for you, we have two problems, reflections and Doppler. To solve such a problem, I want to explain a complicated problem in a very simple way. So the problem, for example, I have two problems, multi-reflection and Doppler. So let's keep the multi-reflection. We have multi-reflections. So we receive multi-reflections of multi-versions of these signals, delayed, and the signal distorted. Okay, this is a problem. Usually the solution comes from the problem. How we can do this? We have multi-versions, right? So since we have multi-versions, let's utilize this multi-version and improve the opportunity to decode the signal. Okay, so this is like the message behind the system. So they receive this multiple, somehow decompose this multi-version of the signal and boost the performance. Another thing for the Doppler, since the signal is moved and the frequency is like moves, deviated from the original carrier, they also, the detector also moves itself with the system and can achieve also a diversity in this domain. So they are trying to overcome the problem and have a diversity from this, like increase the signal performance. So remember this name because it will come up, okay? But another thing, inside the loop, it's also another critical problem. We need to have a channel model before going and adopting such system. And till now, we don't have channel model. I was talking with some of the colleagues how like to short or decrease, make a small scale system and then have some channel modeling. This will allow us to develop communication systems. Also, we need to develop efficient handover schemes and analyze the network architecture. I tried to make the problem simple, but my talk I'm sure that has some complex parts and some simple parts. So feel free to contact me anytime. You can scan this code and email me if you have any questions. If you like to do any collaboration, you are welcome. Thank you.
Thank you, Mr. Osama. Now we welcome Dr. Ravindra Kumar, Chief Scientist, CSIR, Central Road Research Institute, New Delhi, to come to the stage. Dr. Ravindra Kumar will share an insight on strategizing Hyperloop corridor identification.
Very good morning to all of you. I first of all like to thank GSC to invite me here. I'm Chief Scientist working from last 26 years in Transport Planning and Environment Division. The topic here I have chosen strategize the Hyperloop corridor identification. And mostly I will cover about the introduction part, passenger capability of Hyperloop, need of pre-feasibility study, influential factor affecting travel behavior, comparison of factors with respect to high-speed rail, maglev, Hyperloop, factor affecting in the route selections, changes in urban development, experience of HSR in India, maglev, China, and identification of corridor for Hyperloop and conclusions. So all you know that India is experiencing rapid urbanization with 40.7% of population expected to live in urban area by 2030, So this meeting the urbanization is result to the stress on the infrastructures, leading the congestion in the cities. You might have accidents increase, and many of the urban centers like Chennai, Mumbai, Delhi, they are facing the problem. And Hyperloop development expected to address the urbanization challenge by creating the new cities and centers of economic activities. And these new cities can be the globally benchmark, surpassing the existing city infrastructure in terms of planning, city management, and services. As already the previous speaker has told about that, it's a greener, cheaper. I am not going through the details. But what I will tell here that the estimated cost of Hyperloop system in India is around 150 to 200 crores and significantly lower than the bullet trains which are coming in India. So that's the point for you to take, that how to choose the Hyperloop. And one of the analysis done by the Maximized Market Research, they said that if you shift to the Hyperloop, probably passenger capability, you can see over the period of time, it will be much more higher in comparison to the airways. So because the speed of the Hyperloop, if you go through the 1200 kilometer per hour and keep it in the pace, hopefully in the future you will beat the air traffic. So that's what the whole idea of this graph. And also they have covered that there are a potential for passenger as well as cargo. So it's but more on the passenger side, less on the cargo side, you can use the Hyperloop. So, but before planning or before implementing to any place in the field, you need to go for the pre-feasibility study, and that has the component of technical, economic, and environmental viability of the potential corridor. And that affects the route alignments. Land acquisition is the big problem in India. Regulatory requirement is also one of the big problem in India, as well as the potential social impact. Social fabric of India is quite different than the other developed country in the world. So we have to look into all these aspects. Apart from that, environmental impact, you can see here we have to look into the footprint of the material we are using. I am happy to learn about the ideas of the team which are working here, Avishkar team. They are going for the carbon-friendly material and reducing the carbon monoxide, effect of infrastructures, noise pollutions. These are the different effects that has to be looked into. So basically, I will tell from the Indian mindset, like what affect the Indian travel behavior. That include the time, cost, and safety. So if you cover these aspects, probably Hyperloop can become the most preferred mode of transportation. But there are riders. Like rider is reduced travel time, cost effectiveness, safety, and trip frequency that has to be taken care by introducing the last mile connectivity, including the different level of income group, age group, demographic, and having the scheduling flexibility. So distance, size, transit connections, economic productivity, relieving the congestion in the major cities, and integration of mega region, that is the core for the corridor selections. Come to the point of from the different speed, you can see here, already it has been known. Economic wise, if you go here, our Hyperloop has to be priced with lesser than the air travel. So if right now it's like $0.14 per kilometer, and that air travel is coming $0.08 per kilometer. So if you reduce this matrix, reverse this matrix, probably there will be advantage coming to the Hyperloop. So Distance is the factor, up to 500 kilometer, travel time comparison. Also, we have to see that when we are constructing the terminal, whether the check-in process, security scanning, terminal access, if the time taken by this is the same as per the air terminal, probably you will not get the benefit. So that is the one of the most critical aspect we have to look into. And also, we have to see that declining the cost effectiveness advantage over the aviations from station to station if trip length is 800 kilometer. So we have to see how best we can connect to different growing cities because already we have so many metropolitan regions, how we can, like we have in Delhi, we have national capital region. So similarly in Chennai, there is Chennai, then other peripheral part of the Chennai. So if you have the connections between them, so it can add the values by connecting the different tourist point. Already we have the Char Yatra Dham. Those who are knowing the Char Yatra Dham is where we have, government is running the trains, and also the Indian government is very willing to connect all the tourist point. So the tourist point as well as the industrial corridors, they are important part of the selections when we are going for the Hyperloop alignment. Economic productivity is one of the issues. The Surat, Agra, Bangalore, Hyderabad, Nagpur, Tirupur, Rajkot, Tiruchirappalli, Chennai, Vijayawada, they have very high GDP. So this shows you that they have the very much potential for the economic corridor activity. So you can choose the different corridor connecting with the high value GDP. So land, your terrain is one of the challenge. So because when you are going for the Hyperloop, straight line is mostly preferable. But of course, for a strategic reason, you can choose the different area also with different operating speeds at the sharp turns. So that is a way where it can be more scalable because India has the vast terrains, somewhere plains, somewhere mountains. So keeping in that that one way, one speed will be not enough. So you have to be flexible enough for the different type of speed. So there are advantages. Somebody was asking how to get the lands and all. Already we have so much highway infrastructures in place, and getting the medians is not the big issue in India. Means you have the good median available, or by the side of the roads, your alignment can solve that issue. So probably land issue will be not the big problem for the Hyperloop in India, because the requirement is very low. I have experience in all the metropolitan city. You see the metro line. They are just coming on the medians, and somewhere where it is not possible, just to go to the underground if very congested area is there. So that both possibility of underground and elevated has the potential. And also there is need of the political and economic support from the government. That is the one of the important thing. Already our people from Ministry of Railway, they are here and supporting this events and research purposes. So many of the states are, I think, keenly agree, like Karnataka or Maharashtra. So, but still there is hitch because the technology is not mature. So probably once it is matured and it's proven, hopefully you will get the better results from the government support. I have just compared the travel time if you go for the Hyperloop, and I've just concluded that if you compare with the air, because air just direct, I'm just not taking the time taken at the boarding pass and time for security, but just a travel time. And you can see here 60% we can save, 46% to 60% we can save the travel time. So that's the key point where you can address like how much values of the Hyperloop is there. Also, once you have the Hyperloop corridors, probably you will have the urban sprawl and influence of the development strategy. And it has happened with the new start with the RRTS in urban corridor. And then TOD, that is one of the important policy government of India has formulated, like where is the terminal, you can have the development along the terminal. Like one of the example you can see in the metro stations, AIMS, they have redesigned the whole city patterns nearby. That is the walkable approach, and it's like a transit-oriented development. So that is going to be a helpful policy for the Hyperloop. If you develop a Hyperloop and then probably this integrate the TOD, probably your ridership is going to increase. So location of terminal is very much important, and if you have the take care of the safety, securities, and all the scanning of the baggages and all. Like metro also, they are having this type of system where they do the scanning of baggages and all. But of course, you have to check that if all this safety, security, scanning process is taking the more time than the air, or it's the same time of the air terminal, probably you will not get the benefit. So that's the most important point. And this is one of the typical metro, this is the Hyperloop routes planned for the Mumbai. Still it's still under not implemented, but so there are different cost options we have to evaluate while developing the corridors. And if you see in terms of the international pricing here, Los Angeles and San Francisco, or Abu Dhabi, Dubai, or Helsinki, Stockholm, Chennai, Bangalore, the cost is coming 20 million per kilometer. So, of course, that is the key point for the exporting your Hyperloop to other country, because your costing is very less. So we have to see how cost effectiveness is coming into the picture when we are based at India. So this is the point for all the students, those who are working on this, that of course you should have this mind that you are making the things which are cheaper in the world. It's like Chandrayaan. We say that we have made we have sent it at moon with the cheapest price in the world. So same thing, it's going for the Hyperloop. Once you construct and operate it, probably it will be the cheapest solution in the world. So, of course, the good thing about affordability, equity, and impact on lifestyle, once there will be corridor in different cities, they are going to affect the property values. It's always linked. When you give the transportation facility, nearby property value increases. So why I am saying you that it's not only the role of railways, or it's not only role of state government. There are other things like change in the pricings happens, change in the patterns happens, change in the development happens. And I have experience like in Delhi, in Greater Kailash, the property rise increased when the metro line announced. So it means that the building lobbies, how those who are constructing this, they can come forward to support you once you are really comfortable with your trial or test run and then going to implement in the field. So, but the safety and comfort, that is always a question that there is always a criticism about the safety claims. So probably all the designers or those who are working in detailed technical aspect, how the safety protocol they are going to make it happens, that because here chances of survival is I think 0, because so we have to think about that in vacuum tube if something happen, how best we can survive, or what is the survival protocol. So that is the big challenge, and I just put it on the researchers how the best they can go for safety and comfort. Of course, if you are inside the tube, then how best you can create. I have heard that Gabriele, this very beautiful design of the pots, and then you are showing the good pictures. Then probably you can have the beautiful sceneries of the routes. Probably you can put in digital mode when you are driving. So maybe you are inside, but you have the virtual feeling that you are going through the, that is the landscape, video landscape, you can put it on the screen. So that will help you, like if you, even if you are traveling in the Hyperloop, probably you are not in the closed environment, you are in virtually you are in same environment. So that's, of course, environment is the key in the Hyperloop. If the terminals that can be planned with the solar powered, so probably it will help you to generate the energies. And also, earlier speakers has told about that that worldwide flight alone produce 859 million metric ton of CO2. So probably if you just give the options to the passenger, hopefully this flight travel will go down in the coming future. And because you are decarbonizing the whole transportation process. So once you decarbonize this, you will get the benefit of carbon credit. That is the another aspect probably nobody has thought about, but you might be surprised to know that metro in Delhi and metro in other part of the country, they are using the carbon credit protocol, and they are getting a lot of concessions and lot of benefit with the carbon credit. So probably this angle you can add into the getting the benefit of carbon credit, because you are doing the not for transportation, you are doing for the climate change. So if you align your agenda with the climate change, probably you have a more benefit available what the doing support for the climate change. So of course wildlife aspect is not here, because there are either it will go underground, and even if it is elevated, there are no issue of the for the wildlife, disturbing the wildlife. But yeah, in India we have environmental impact assessment protocol. So we have to go through that. There are wildlife protocol, we have to go through that. So all the Environmental Protection Act, for any project, when you are going to develop, we have to go through the all this clearance of EIAs from the government. So of course, this has been the environmental friendly alternative. I talked about the routes, like you can have the routes along the expressway or along the highways, and maybe the along the railways near just aside. Probably that will give you the no problem land acquisition, because most of the places lands are there. Of course, you have to take care of the noise or potential annoyance which are coming with the public transport or non-motorized transport. I will tell you the just one critical study for the Delhi Ring Railways. Ministry of expert from Ministry of Railways are here. They might be aware about that this ring railways failed. It was constructed long back in 1980, and why it is failed? Because of only lack of integration with the feeder service. There is no feeder service. It's a very huge investment they made it, and ultimately it failed. Nobody is using. So why I am telling you this example? Because whenever you are constructing the infrastructure, such a huge infrastructure, ultimate goal is to make it for the public. And how you can make it with the public? Either you provide the feeder service or proper connections with the bus stations or nearby some sort of metro stations or RRTS or any terminal, air terminal. So basic idea is it should give the proper connections with proper scheduling, proper time frame, proper security. Then probably we'll have the better options. So now they are planning for revival to integrate the ring railways with the existing metro stations. And also they are giving some different options for the tourism explorations and all. was creating the public plazas, walking, cycling facility nearby, so that even public can come there with the cycles and park their cycles. So Hyperloop has the impact on the intercity accessibility. So we have to see that how the intermediate stations at every 500 kilometer that can be used, 500, 800 kilometer, that can be give the mileages within the countries. It unifies the country. Basic idea is to unify the country from northern part to south or east part to west. So there are experiences. When you are going to implement, there are experiences for high-speed rails. I'm not going in details about high-speed rails, already given. In India, we have the first RRTS, Rapid Rail Transit Service, already in place with maximum speed of 180 km per hour. So this will be giving you exercise or experiences how the city is changing, what are the problems they are facing. So once you go through these details, probably you will have the more idea in the Indian context, like how the high-speed trains is going to affect the, and how is their performance, whether the ridership is okay, whatever they have invested, whether they are getting the proper ridership or it's failed project. So that is very critical, even the bullet trains that is coming to India. So all these things we have to see, although they try to include the multimodal transport integration, safety, sustainability, and they have the target like improve the modal share from 37% to 63% in public transport. Probably they are also having the target to reduce the carbon dioxide emissions. So this, you can see here the integration aspect. One side is metro station, other side is railway station, and then they are integrating with the walkway. So that's the way, when sometimes you don't have the available space, then probably how to integrate with the metro. So probably this is the one model, and this can work for the Hyperloop also. And whole idea is that Hyperloop should be that it should be the commuter centric. How best you can integrate with the public transport system, how best you can have the lower cost, how best you can integrate with the airport, bus depot, whatever possible way, metros. So once you integrate, probably your ridership will be increasing and the project will be more viable. And of course, there has to be trade-off between accessibility and speeds. Sometimes if you have so much ridership there, then probably your speed has to be compromised. So that is the other services, like in cities area there are metros, but you go to the next level, it can be the Hyperloop with higher speed. Metro average speed is 80 km per hour or 60 km per hour, but here you can have the more higher speed. So probably you can have having the with higher fare with more better service with the Hyperloop. So idea is to trade off between accessibility and speed. Maglev is one of the example. Here they have connected with the airport. So Maglev services is basically connecting the Shanghai city to the airport, and that's the way they have increased their ridership. So it's like a feeder service. It's acting as a feeder service, not as a primary service here. There are many experiences. They have a very good ridership. And if you see here, Maglev got 11% total share out of car, taxi, or charter buses. So that's the good example he is giving you, that even Hyperloop will have the similar future. But of course, the integration is the key component. And they have done the surveys and they found that what are the key challenges they are facing, and that lower speed of metros is the major key challenges. That's why they are shifting to the Maglev, because it takes a lot of time to reach even 40 kilometers. Then shortage of airport buses route, and then high price of Maglev, and long waiting time for the taxis. But same thing has to be done for surveys at Indian airport level, what the airport passengers are facing. Once you have this data available for Indian condition, probably you will get the better idea what is the lacking for the air passengers, and probably with that key parameters you can use it for the your Hyperloop aspect. So they have done the surveys and they found that time cost is one of the important for air passenger travel, and then money cost, reliability, comfort, convenience. So these are the key parameters that will affect you when you are going to select the alignment or select the places, locations, terminals. Now the new trial is coming from Tokyo to Nagoya. This is another exercise in Japan they are doing, and let us see what is the. But they already they have started this work. And I'm not going in details, but what I want to tell that Hyperloop terminal will have the impact on the urban development. Many countries like London, Paris, they have seen that the land price goes up, property prices goes up, and it influences the whole urban dynamics in total. This is the high-speed railway corridors in India. They are targeting from 300 to 350 kilometers per hour. Some of the places they have proposed, some of them find feasible, and this is the total details. You can go through the website. It's a total. Somewhere it is proposed, somewhere it is at DPR level, and this is the target line. They have done the target line in 2051, 2031. I think there is need to have the planning for the Hyperloop in India also. We don't have such type of still plan in India, like what type of, where we can have the feasible line, or even dotted line, what could be the current status of this. Because once we have this plan, probably you know that it links with the development, and development with the primary zone, development with the secondary zone, and development with the tertiary zone. Basically, primary zone, it's coming impacting of up to 800 meters, and then secondary zone impact up to 5 kilometers, and then greater than 5 kilometers is tertiary zone. So once, even if you announce the locations, that will have the impact. But to announce the location, you have some idea, some surveys to be done, and some potential, where could be the potential locations that has to be announced. So that has totally linked with the urban planning and public participation to integrate the Hyperloop. So you can have in India, we can have like every year we do some sort of household survey. We have the census survey in India, but we do not have the transportation surveys. But in UK and other countries, they conduct the transportation survey where they try to find out what is the basic problem they are facing in day-to-day life. So probably that survey we can do it and get the idea like how we can integrate with the Hyperloop. So basic idea is to have the integration between Hyperloop and urban transport network, and that is going to play the vital role in shaping the urban transport system, ensuring the seamless connectivity of the passengers. And accessibility between the urban nodes is crucial, and that is influenced by proximity, node size, and transport quality. So basically, it's all about the fostering the cooperations, avoiding the competition, and connecting with the regional services. So this is the few routes. I will just like to show you here. That route has been given by the Hyperloop One company, and this is the DG Hyperloop. They have given the routes, probable routes in India. You can see it here. This is what the population density map. So based on this population density map, you can see this northern India, where is a very highly populated one. So this gives you idea like where the railway is not able to cater their passenger demand. So probably this northern India, they are the very big choice, and then Mumbai, Surat, Ahmedabad, Chennai, Bengaluru, Hyderabad. So these are the cities, they have the higher density. So based on this density map also, you can decide what routes is feasible. Some of the routes has been given in some of the literature, that is from Bengaluru to Chennai, Chennai to Mumbai, then Mumbai to Delhi via Ahmedabad. So these are the typical routes. So my vision is like, if you go in the back, we were pedestrian, long back. Then we become, some of them were becoming the cyclist, where the cycle came, then we become the cyclist. And then when the two-wheelers came, then we become the bike riders, motorcyclists. And then car came, then we become the car-dependent society. And now we have the Ola, Uber, and other aggregators. So probably there is shift from the personalized car to the aggregator society. That is also a very new revolution in the transport. And when the metro came, then there is a shift from the buses service to the metros. And then from metro to rapid rail transit. That is the another shift is going to be happen. Then what I am expecting, like in future, air transport, probably similar way, when Hyperloop will come into the picture, probably we will shift from the air transport to the Hyperloop. Because in the air, minimum travel time is 2 hours minimum. Because even half an hour is travel journey, but your boarding times and all, it becomes the means 1.5 hours of travel journey plus 0.5 hours your boarding times, waiting times and all. So it makes you total journey time 2 hours. Probably if you get rid of this, the Hyperloop system will be efficient. And this is the travel journey map I have prepared. You can see here, like if you diminish this boarding time or security time, probably you can reach to different destination by different, just by going through this. This is showing you the travel time journey map. So I'm coming to the conclusion that rapid development of new global cities to boost the Indian economy, and Hyperloop development in India can result with employment, advanced infrastructures, economic development. Hyperloop corridor development requires pre-feasibility studies. It can become effective among all the alternative of transportation if certain criteria are met, like reduced travel time, cost effectiveness, and ensure the safety and government and political support as the decarbonization of transport. Trip frequency is influenced by the several factors that are the last mile connectivity. I always talk about the last mile connectivity, then income level, age group, demographic, and frequency of schedule, how much frequency is there. And secure integration of Hyperloop with other mode of transport. We have the railways, we have the waterways, we have the airways. And then integration allows the Hyperloop to connect with the regional service, fostering the cooperations and avoiding the competition. Harmonized timetables, connections encourage the efficient use of Hyperloop, sustainable transportation mode, increase the spatial penetration and passenger accessibility. Hyperloop may utilize the existing infrastructures. Existing means side of the expressways or highways or metros or railways to develop the line stations or terminal. It can, by saving the cost, travel time, easing integration with other mode of transport. So overall, this framework can be useful, but of course, it requires a lot of data. So thank you very much. Thank you. Are there any questions?
Thank you, Dr. Ravindran. Our next topic will be presented through online. We have Dr. Wei Shi, professor from Heihuzhou University of Science and Technology, China. He'll be sharing us the efficiency improvement on liner induction, mission and drive systems. Dr. Wei, you can start now.
Sorry, so start now.
Okay, so can I start? Sorry, can I start my presentation?
Yes, Dr. Wei, you can start.
Okay. Good afternoon, everyone. It's my great honor to give my presentation, Efficiency Improvement on Linear Industrial Machine and Drive Systems. I will give my presentation by 4 parts. The first one, introduction of linear machine and systems, especially on the linear industrial machine, which is a fundamental member in the family of linear machines. Then I will give the brief introduction about how to design high-quality linear industrial machine. After that, I will especially talk about the efficiency improvement method, efficiency optimization control for linear industrial machine and drives. And finally, I will draw conclusions. As we know, the linear machine actually is has a short, younger history than the rotary machine, almost 40 years younger. So linear machines can realize the conversion of electrical energy to linear motion, mechanical energy directly. So especially in some industrial applications, the linear motion actually can drive by the linear machines, which can benefit from the greater acceleration or deacceleration, and the lower noise, and much stronger climbing capability, and so on. So since 1960s, almost 6 years ago, so linear machines has been paid more attention by industry and academia, and also it suffered from the great challenge. So especially actually requires the high requirements from the control and the converter systems. So generally, linear machines can mainly include the linear sequence machine and the industrial machine, the similar as the rotary machine family. Here, this slide gives you how the linear sequence machine comes from the rotary sequence machine, and this slide gives you how the linear industrial machine coming from the rotary industrial machine. So then we can see potential applications of the linear machines. I just actually use the 2 slides to mainly summarize the actually the typical applications, including the linear accelerator used for the aircraft carrier. So also electromagnetic railgun. Or another big application is the linear metro transportation. Till now, by my knowledge, there have been more than 30 transportation lines around the world, especially in Japan and China. So take the past 15 years, for example, there have been more than 10 transportation lines among China. So in the coming 10 years, there will be other more 10 lines to be built up. So also included the maglev. maglev is for the high-speed transportation. So the linear metro is for the low-speed transportation. Linear metro actually the speed is no more than 160 kilometer per hour, and the maglev actually in China. So in last year, so 600 kilometer per hour. So and the working principle is similar as the transrapid system, the Germany transrapid system. Also, another typical application is a Hyperloop. I think everyone in this conference is familiar with such issue. So it actually has a big challenge for the machine, for the electric machine, for the drive system, and for the control strategy, and so on. So other typical applications include the linear elevator or linear compressor or left generator or linear driven wave energy conversion system or linear oil sucking machine from the underground. Also include the extended transportation system actually produced coming from the Germany, and also included the servo system, linear servo system, and other bridge detection system or careful steamer drive system, or even for our cellular phones or other more industry application. So in the coming 10 or 20 years, so I believe the linear machine can find more and more application. So why we choose the linear machine? So because it can get the following merits, including the low initial cost, and also can get the high reliability for it direct drive by the electromagnetic force. Also, it can get actually the much better position tracking or greater acceleration or deacceleration. However, in response to the rotary electric machine system, the linear system need a high performance power electronic control and adaptive the system level design methodology and so on. Today, my topic will focus on the low-speed transportation system, the linear metro. So I think everyone knows this application. This is a typical actually application. There's a simple picture here. So we actually install the primary, the stator, on the vehicle body by the boggin, and at the same time we put the secondary along the track. So in order to guarantee the safe operation, so the mechanical air gap length usually more than 6 millimeter. So this slide give you actually how the rotary industrial machine and the difference and the similarity between the industrial machine and the linear industrial motor. So here, so the typical application around the world, including the Canadian line in New York, and the Malaysia and Japan, and this last two picture is the Guangzhou Line 4 and the Beijing International Airline commercialized in 2025 and 2028. Just mentioned before, I gave you some merits. Unfortunately, this system also suffers from some shortcomings for its large air gap length. So the system suffers from the lower efficiency. Typically, the rated working efficiency is about is no more than 75%. So we should try to increase the working efficiency from both design and control. So next we'll talk how to design this machine. So firstly, let's look at the traits, the special traits for the linear decimal machine system. Here, I summarize the 4 traits. The first one is the large air gap length. The second one is the end effects, especially the longitudinal end effects. So as the speed goes up, so actually the eddy current will produce anti-direction flux linkage in response to the fundamental flux linkage in the air gap, which would actually decrease the average flux and then decrease the thrust greatly, even under the constant excitation current. So the third trait is the half-field slots in the primary ends. So which actually will result in the unbalanced magnetic circuit, or also decrease the air gap average flux density. And the fourth trait is the vertical force. Due to the unsymmetric structure in the cross section, so usually, so it will actually produce a large attractive force, which would actually similarly increase the weight of the vehicle body. Here, I summarize, make a comparison about the efficiency and the power factor between the linear decimal machine and the rotary decimal machine. So mainly due to the air gap length. So I can say the air gap length in linear decimal machine is about 10 or 20 times, or even 20 times of the rotary decimal machine. It will actually decrease the efficiency and the power factor greatly. Average level, so actually the efficiency and the power factor actually are much lower, so 10% or 20% lower than the rotary decimal machine. Here, this picture gives you actually understanding how the eddy current decrease the average flux linkage. So this dot line is the constant flux linkage actually at different rotor position, while unfortunately, due to the eddy current effection, so the average flux linkage in the linear decimal machine would decrease gradually as the speed goes up. So here gives you some how the flux density get a distortion as the speed goes up. So for the cut end, for the cut end in the primary, here, so give you a further understanding, the flux linkage actually decrease as the speed goes up. The red lines is low end effect, which means that at a different rotor position, actually the flux linkage is constant, is the same. While as the speed goes up, for example, from the 0 meter per second to the 80 meter second, so the average flux linkage would decrease almost 20% of the standstill flux linkage. It means that even under the constant excitation current, so the average thrust would decrease almost 20% of the standstill or the thrust. It will actually deteriorate the drive performance greatly. So that's why the linear induction machine with a short primary structure, difficult actually to apply for the high-speed transportation. So it actually can only apply for the low speed, the linear metro. So as the flux linkage decreases, so the mutual inductance also decreases at the same time. So this slide give you, as the speed goes up, so the mutual inductance decreases gradually. Okay. Then we can actually build up the equivalent modeling, the circuit to design this machine. You can find many papers from the actually explore starting on the modeling for the linear induction machine. Here, so this slide I will give you the modeling proposed by our group. So we actually use the four coefficients Kx, Cx, Kr, and Cr to describe the inference from the longitudinal end effect and the transversal edge effect, especially the longitudinal end effect actually will give more influence on the drive performance. So we actually, by a very complex mathematical evaluation, we can finally get the equations for the coefficients. So if you are interested, so you can find the papers from our group. So then we can get the T model for the steady performance analysis. So then we can use this model to design a different type of linear induction machine. Firstly, we actually make a careful study and a comparison about the Japanese 12,000 linear induction machine, which is the typical machine widely applied in the linear metro. So we can actually get the drive performance curve, such as the power factor, thrust, efficiency, and so on. Then we can also study the vertical force. So we can get a reasonable, results. And the next step, actually, we use this mathematical modeling to design several linear induction machines. The first one, we use our model to design different rated power linear induction machine for actually the transportation line among China. So this is for the Guangzhou Line 4. And this is the demonstration platform in our group. So we actually use the arc-shaped induction machine so to simulate the practical linear induction machine movement. Okay, that's all for the design of the linear machine. So the next part, we will discuss the efficiency optimization control, also called the loss minimization control. So from the control strategy, actually, the loss minimization control for the linear decimal machine is similar as that for the rotary decimal machine. So in our study, we mainly contributed to the equivalent modeling for the linear decimal machine and the drive system. So here, this slide gives you briefly the loss minimization control, the categories mainly include the offline and the online. So generally speaking, so we actually employ the model-based, the hybrid model-based loss minimization control. So it actually can get actually reasonable accuracy and also can get a dynamic response, and reasonable dynamic response, and so on. So firstly, we actually apply our T modeling to the DQ, dynamic modeling. So then we can get this equivalent model for the control strategy. Similar, just a little difference with the rotary industrial machine, we can say the different coefficients actually here. So for the mutual inductance and for the secondary resistance, this is a special traits. So these coefficients come from the magnetic analysis for the machine. So we can actually to use these coefficients to conclude the inference from the undercurrent, from the under effects brought by the undercurrent in the secondary sheet. Also, we actually consider the influence of the core loss, the air loss, especially in the practical application. So the air loss is a little larger than that of the rotary industrial machine. So then we actually build the steady state loss minimization control, include the voltage equations, flux equations, and also this is the current equations. So here, so as we see from the flux equations, we can say actually just a little different. We actually use the different coefficients, Kr or Kx and Cx, to modify the mutual inductance online. So which is mainly brought by the end effect. So then next, we actually build the relationship between the power loss and the current. So we must try to find the solution from the by the current and the linkage. So then we can actually to modify the current to use the minimal current, the d-axis current, to get the same output thrust. So then we can actually get the minimum loss, which means that we can get the maximal efficiency. So this is the main idea of the loss minimization control. So frankly speaking, due to the influence of the end effect. So the actually coupling the non-linear coupling between the current and the flux. So it's difficult to get the actually simple mathematical equations between the d-axis current and the rotor flux linkage. So I have one PhD student who spent more than half a year to find the relationship, and then we can get the results here. I just only give the results directly, so just like this. So if you are interested, you can actually find more details in our I2AE translation on industrial electronic, the paper. So then we actually apply our method, combination of the LMC, loss minimization control, and the field orientation control. So in general, the control diagram is similar as the rotating industrial machine. Just here, so the optimal flux and current conclusion is special. So based on coming from our contribution here. So then we actually do lots of experiment in our plan form. So we actually can get different experimental results at different working conditions. Here, so we actually use different speed and different loading. So including the light loading or rated loading and the heavy loading, different loading at a different speed, low speed, rated speed, and actually the high speed, and so on. So we can say, based on our linear loss minimization control, we can get a much lower loss in response to the traditional FOC. So for the time limitation here, I briefly give you the results. So we actually get a good results by using our loss minimization control. So next, we continue to actually consider the influence from the power converter. So just now it's only the linear industrial machine, and the second step, so we include the loss of the converter. So first step, we actually build the loss equations for the inverter. So it's very easy to get these equations from the actually the data sheet of the converter producer. So here we can actually get the equations. Then we actually combine the inverter loss and the machine loss all together, and then we can actually get the total loss by complex mathematical equation. Then we can actually finally get the relationship between the the flux and the loss. So then next step, we can continue to get the current and the flux, the relationship. So then as we can say, it's just a little difficult. So fortunately, we actually get the final solution. And then we continue to do experiment. And here this slide gives you our method, proposed method in comparison to the conventional method. This method actually not include the loss by the converter, and our method include the converter. So then we can actually see the main results. So we can continue to reduce the actually the loss, and finally increase the efficiency 3%, almost 3%. Okay, so also we do some research to reduce the LOMO, the vertical force, based on our loss minimization control. So for the time limitation, so I will actually give a brief introduction. So we actually firstly build the vertical force mathematical equation, and then we actually also find the relationship between the dx current to the actual flux linkage. So then we actually can also modify the current to try to use a minimize the current to get the same output thrust. And also, fortunately, we can actually reduce the vertical force. So here, this is the main results. So we can actually reduce the vertical force, and finally we can actually reduce the loss, almost 2% on average. So should be mentioned here. So we actually just get some general results. So if our working condition or our drive system change, so maybe the results just have a little change. So we believe, so actually if we actually use a high power leading decimal machine, so we can actually get a much lower or get a high percent efficiency improvement. So I just skip this slides. Then also we actually check the dynamic response. Generally speaking, so the dynamic response is just a little slower, a little slower than the traditional FOC, while also it can also quick and also can satisfy with the engineering application. Then finally, I will actually give a brief introduction about the drive cycle, because the drive cycle is very important for the transportation, especially for the subway, the linear metro. So usually this is a typical speed curve. So the zero increase from zero, the speed increase from 0 to the maximum speed, and then for the cruising, and then after that decrease to the 0. We actually applied the loss minimization control due to the cruising, and in order to reduce the simulation time, we just started the half cycle, because in the another half cycle, so it's similar with each other. So we actually we have done many simulation and experimenting. So we can actually use this table. summarize the energy saving, the saving energy. So you can see, so as the duty cycle larger the duty cycle is, so the more energy reduction can be got. So we actually will modify the duty cycle, the ratio from the actually 50% to almost 90%. So actually we can say get more and more, we can say save more and more energy. So, okay. So finally, actually, we make a conclusion. The linear method, how say, have been applied widely during the past 20 years. While, so due to its lower efficiency based on the traditional structure of the linear dust machine, so it is very, very difficult to find more wide application by the current technology. So in order to, to widen the commercial market, so we must try to find the new topology for the linear dust machine. Also, we can actually try to apply the advantage control strategies, such as the efficiency optimization control, and so on. Also, the system level optimization strategy is very important. We should better try to increase the efficiency from the system level point. So another application is a high speed MATLAB. For example, the Hyperloop. So actually, which is a very popular issue. So it can be driven by the the superconductivity linear machine system, or also can driven by the linear dust machine, not the short primary, but the double side short secondary and the other special topologies. Well, so the drive system also a big challenge, suffer a big challenge. Besides the transportation, in other industry application, in need of the linear motion, so linear machine can find a wide application. So as to the emerging technicals in the future, I believe so we must pay more attention to the system level optimization and control. Also, we should actually combine the the new materials for both the converter, for example, the silicon carbide, especially for the high speed applications. Also, we can use some new materials for the machine and so on. So also, the advantage control strategy can also find a wide application in the field of the linear machines. Most recently, the model predicted control, as we know, a very popular issue. So it can reduce the switching frequency, which is very, very attractive for the high power application. Once the switching frequency decrease. So it can actually reduce the converter loss greatly. So also the model political control can, reduce the thrust ripple in response to the field orientation control and so on. Okay, so here this slide gives you the system level methodology, some brief idea. So from these two papers, so we can actually apply this method to the linear decimal machine and the drive system. Also, we can actually combine the co-simulation technology combined with the finite element algorithm and the equivalent modeling, the circuit modeling, to actually to study the linear decimal machine and the drive system. Okay, finally, I will actually conclude by my presentation. So here I give the some papers or books coming from my group. So we have actually almost online. So for the time limitation, so I just a brief introduction some ideas. So if you are interested, so you can find more details from my papers. Okay, that's all my presentation. Thanks for you. Okay. Any questions?
Thank you, Dr. Wee. Thank you for your presentation.
Okay, thank you very much.
Now I request... Now I request Mr. Mars Gershe, Chief Hyperloop Officer at HERT, to come to the stage. Mr. Mars will share the insight into about developing the European Hyperloop ecosystem.
Hi. Thank you. Thank you, everyone. Yes. Always a pleasure to be in India. Very inspired again by the energy here to develop this Hyperloop system, bring the railways to a next level. Very exciting tour yesterday again, learned a lot of new things about the things that have been done by the Avishkar team. And good presentations just now already, where I learned a lot about the communications, about linear induction motors. I was impressed by the work being done by the TUN team as well. And yeah, now happy to introduce to you a bit more what the things are that have been done by the European Commission to accelerate the development of Hyperloop. I'll explain you a little bit about the things that we have already done in terms of tests and also what some of the technological choices are that we've made in the tests that we've done up to now, and then provide some insights on what next steps could be. But first, going into the challenges, I'll skip through it quickly because we've heard all about this. But for me, personally, what drives the reason that I'm working on this is that we see a massive growth in the demand of transport. This will put a lot of pressure on different parts of society, the noise and the pollution, congestion on the roads, the energy consumption, but also the land use. And I feel like we need to develop solutions, but also changes in behavior, which will help alleviate these issues. What I always like as a sort of a visual image is that if our issue is that we have congested roads, then the solution is not to widen those roads. The solution is to provide excellent public transport systems, mass transit, shared mobility solutions that make people make the sustainable choice themselves. So this means across the board, we should promote shared use of modalities, less private car use, more use of, for example, buses, mass transit like metro and rail solutions. But we also see that Hyperloop could play a very important role in this new mode of thinking more about mass transit. So we know all what a Hyperloop is, so I won't go into the details of what it is, but I do want to note the three main things that I think that Hyperloop brings. One is the reduced energy consumption, about 10 times lower than aviation and road transport. The improved spatial integration. Not only does it use less space than a road or a rail that provides the same amount of capacity, but it also provides no noise and no vibration, so it's easier to integrate in an urban environment. And if you run across, you know, the typical engineering cycles and cost improvement curves over a long term, I really believe that Hyperloop can be substantially lower cost to build and operate than high-speed rail, which will mean that it will need fewer subsidies from a public sector to run at a competitive rate. I think if you build Hyperloops, and I really like that also in the presentation before about the transit-oriented developments, it will really change the way in which you operate. So it increases the distances at which you can live and work up to about 250 kilometers. So that means that you can both connect, of course, longer distance cities and replace the aviation, but it also allows you to connect several places in between to further spread this urbanization and make sure that you have dedicated spaces where you have very high density development. Now, what we estimate is that the total market size for Hyperloop will be about 150 billion. What that is estimated on is based on that there's about 100,000 kilometers of high-speed rail in planning or in proposed around the world, and about 3,500 kilometers is being built annually. But if you look at the potential advantages of Hyperloop, it's basically faster, more cost-effective, more reliable, and more efficient. So once Hyperloop is fully demonstrated, why would you still build high-speed rail, right? It makes much more sense to build Hyperloop at that point. So we think that a large part of the budgets that are already being allocated to build high-speed rail can be shifted to Hyperloop. And it will also help actually the existing railway systems, because we can offload the higher speed trains off of the railway network, which means that you have more capacity for commuter trains, freight trains, and so on. So although it might compete on the budget for the CAPEX, I think it will improve the overall operations also of the other modalities. But this is, once we have a Hyperloop, right? The big question is, how do we get a Hyperloop? And I think more and more governments around the world are seeing that this is not just, you know, a new transport system, but it is also an opportunity to build a new industry, to build an economy around that, and build a supply chain that can supply a system to the world. And Europe is also one of those places that has seen this, that is grasping this concept. So first, they recognize the challenge, so they're already banning short-haul flights in countries like Spain, Germany, and France. And it will just be a matter of time until this will be done on a European scale, that we will ban short-haul flights where there's also an alternative. And I think one very striking comment from the CEO of Lufthansa is that to use 100% sustainable aviation fuels, they would need half of Germany's electricity. And so it is good that we electrify. Electric mobility is the future, everybody agrees on that, but we also need to drastically reduce the energy consumption. And this is, of course, where the Hyperloop comes in. So you see many European governments have been investing in Hyperloop, and I feel like this has gotten to a critical mass. European Commission themselves invested into it. There are several governments in the Netherlands co-investing into a test track. In Italy now for a feasibility study for a new test track. In Spain, in Zeleros. And in Germany, of course, we've seen the results, or maybe Bavaria, but it's still the public sector there that has invested into the development of the test site there. The EU is starting to establish their regulatory framework. They're currently in the impact assessment stage, but the best case that they have provided there is that they are looking into setting up an actual agency for Hyperloop. So there's a very high ambition level there. It's included already in the European policy and the mobility strategy. And also the EU has just started a harmonization roadmap call. So they're inviting players in Europe to work together to set up a roadmap towards harmonization. So Europe is really taking good steps there. And one of the major things is that there's a new test site live in the Netherlands. It's an open test track. Of course, it uses a specific technology, but it helps in getting multiple parties to develop around similar concepts, such as start having a harmonization effort there. This is done under the flag of the Hyperloop Development Program, which is a broad public-private partnership with several Hyperloop developers and lots of industry partners taking up the gauntlet to really turn this into an industry solution. Now, the main specifications of this European Hyperloop Center in the Netherlands is it's a 420-meter test track. It will allow speeds of around 80 to 100 kilometers with the current design, but you could probably make improvements on the vehicle to also achieve a higher speed within this track. The pressure is 1 millibar, which we believe is going to be the pressure at which the final Hyperloop will operate. And there's a lane switch. If you look at the image, you'll see that by the end of the track it splits into two parts. So it can also demonstrate vehicles merging and diverging into the infrastructure. And the technological choices for this infrastructure are topsides, electromagnetic suspension, electromagnetic on the sides as well for guidance, and a linear synchronous motor. And in a bit I will also explain why we decided to go for these technologies for this specific test site. We as a company have been steadily making progress, first by competing in the Hyperloop competition of SpaceX in the first cohort, then building a low-speed test facility in the Netherlands, also about 30 meters, just to demonstrate the core workings of the technologies. We learned a lot from that. Actually, in this test track, you see the cables on the top. We had a linear synchronous motor in the track, but then we shifted towards having a motor on pod-based propulsion, because we do believe that making the infrastructure as simple as possible and putting the technologies which can also evolve over time on the vehicle is a better solution to minimize the capex and maximize innovation for the long term. Now I wanted to give you the perspective of why we selected some of the technologies we chose for. The first is the comparison between electrodynamic and electromagnetic suspension. So electrodynamic is where the magnets are on the vehicle. You move the vehicle over the track, induce a magnetic field that pushes the vehicle up. And the electromagnetic suspension is where you have steel beams in the track and you have magnets that pull itself towards the steel beams. Now I see a very, very big benefits of electromagnetic versus electrodynamic, because electrodynamic uses relatively higher expensive materials, copper or aluminum tracks. It has high stray fields because there's no closed circuit with steel. You have magnetic fields that are quite far dispersed, so you need larger tracks, larger distances towards the passengers, or you need a lot of shielding, and it limits the possibility to use steel in your tracks. And there's high losses because you need to generate currents in the infrastructure in order to levitate, which reduces the overall efficiency of the system. Conversely, electromagnetic uses steel beams, so that's lower cost materials. The stray fields are minimized because you've got the magnetic circuit is closed with steel, and it has lower losses because you don't need the ether currents to levitate. And one big benefit that's not on the slide is that you need a extra suspension for electrodynamic because you need to move first before you start levitating, and electromagnetic always levitates. So I like to see that, at TUM, and also Tutor and Avishkar, we've all came to this conclusion that electromagnetic suspension is probably the best way to go. However, we do see one thing in a typical electromagnetic suspension solution that we see very challenging, and that's the lane switch. So this is the electromagnetic suspension used by Transrapid in the the Chinese train between the airport and Shanghai and the city. And in order to make a lane switch, sorry, let me try to. In order to make a lane switch, they have to bend the entire infrastructure from one track to another. Now, of course, this is an engineering marvel, right? Being able to bend concrete in this way, but the ideal way would be that you wouldn't have to move anything in the infrastructure. So what we decided to do was instead is to levitate on the top side of the infrastructure, so we're hanging underneath it. And that means that we don't wrap around the track anymore. And if you don't wrap around the track, that means that nothing blocks you anymore for making a lane switch. So if I show you what the cross-section of our infrastructure looks like, here you see the basically the tracks. All the tracks on the sides, so the levitation, propulsion, guidance, and braking, are all simple steel tracks, nothing fancy, just passive tracks. And all of the active components are in the vehicle. We did add one center track in the top middle, which is an inductive transfer system. So for parts of the track, we inductively charge the vehicle. It's almost like a catenary, but then without any friction, to provide the high power needed in high power sections. So, you know, I see two solutions here. It's either using a booster motor in the infrastructure to boost up the vehicle, or you do something like this where you inductively charge the vehicle in those places and still use the propulsion on the vehicle side. But I think both solutions are very good. Now, why is switching so important? And that's because we want to do these kind of operations. We want to be able to have vehicles in a main line go at very high speeds, and then have vehicles merge into the network, diverge again so that you can go into any city and connect many places along a corridor. And I'll show you in a few slides what that means on a European scale. The other solution that I wanted to emphasize, I see that my picture of the linear induction motor is gone, but you just saw it in the, in the previous presentation, so I think you can imagine. We deliberately spent a lot of time looking at what the different solutions are for motors, and although I see a lot of benefits for the linear induction motor in the innovation stage of Hyperloop, because it is a relatively simple solution, you just need an aluminum track, you know, you can achieve high speeds with it, and I think we can use it in testing situations to show high-speed operations and do tests with that. If you look at this from a final scaling up perspective, the two big criteria for motor selection for us is, one, the efficiency, because we absolutely need to minimize the amount of heat produced, because getting heat out of the tube is very difficult. And the other one is basically the mass on the vehicle. We have to minimize the vehicle mass because that has a waterfall effect. The lighter the vehicle is, the lower dynamic aspects on the infrastructure, lower infrastructure costs, and so on. So if you look at the sort of performance characteristics of a linear synchronous reluctance motor versus a linear induction motor, the efficiency is much higher, so there's a much lower heat generation, but also the stator weight is much lower, because you don't need to generate all the currents to interact with, right? Most of the forces are coming from the reluctance and the steel that's also in the tracks. Now, the track of a linear synchronous reluctance motor will be a little bit more expensive than an induction motor, but over time this will easily pay itself back with the lower energy costs. So I wanted to give that perspective because induction motor is often mentioned also as a solution for Hyperloop, and I do think it has its uses, but I also think it's important to take into account the longer term implications of that. Now, what we've been working on is basically developing all of these magnetic drives, components for levitation, guidance. That's really what we've been focusing on, and making test setups for each of them. So we have static test setups for the levitation system. We have dynamic setups where we move the track very fast and simulate the movement of a magnet going across an infrastructure. We've made frames simulating the track topology so that you can also test vehicles outside of an infrastructure. We did an integrated test already of the entire system, and now at the European Hyperloop Center, we want to test that also in the coming months to demonstrate it also in an integrated system for longer distances. And one that I forgot to mention is also, of course, a propulsion wheel where we simulate the motor, linear synchronous reluctance motor, by spinning up a wheel but having the magnets on a static plate. This is just one thing we did. We just saw the presentation also of other parties working on that, and there are many of these, right? There's about 8 parties in the world doing these kinds of developments. I think the most important next step is that we take all the learnings from these facilities and put it together and look at what the ideal specification would be for a first real certification facility, where we go into longer lengths, go into higher distances, certify it for real operations. I right now see in various parts of the world the developments for this. So there's actions in India to prepare for this. There are developments in Spain and Italy with large budgets preparing for this kinds of facility. And I think it's very important to already align on that on a global scale, right? Because if we can industrialize this solution with a harmonized solution that crosses the global border, so to say, I think the entire industry will be better off because we can compete on each other's markets. It will drive the costs down of all the solutions. Finally, you can also cross borders, which improves the operational performance. So standardizing this is very important. So I think going towards this certification facility, we should really get all the great minds together and converge and harmonize to a solution that we can all back. Yeah, that's what I wanted to share. So looking forward to working together with you on taking the next steps.
Thank you, Mr. Maas. Now I request Mr. Harjit Dirwal, Chief Business and Capital Program Officer of Nivomo, to come to the stage.
Okay. Well, first of all, thank you very much for giving me the opportunity to be here today. It's an absolute privilege. I think the last time I was in Chennai was exactly 10 years ago, and even driving around here, I think the metro was under construction when I was here, and there's diversions everywhere, and I think I was here in the rainy season. To actually come back now to Chennai, I see a lot of the metro now completed, and normality in the city is actually fantastic, albeit the humidity is still very, very high here. So thank you to the professors, you, the students, for actually giving me the opportunity to be here, and all the staff here at IIT Madras. I think it's fantastic that IIT Madras and the Avishkar team are all taking a lead here with Tutor coming in and looking at how we can commercialize some of the technologies. And what you'll see as I go through my presentation, it's a bit unusual today because it's a two-part presentation I'm doing. I'm going to do some slides, and then I'm going to actually open up to a few questions that a lot of people have been asking, may want to ask. So we'll have a bit of a Q&A at the end of all of this as well. But we're actually overrunning on time. The idea was that I was going to come on at 12:10, take half an hour, but I also realized that in this slot there's a 20-minute buffer. And I was going to then use the buffer to carry on and make the most of the time. But we'll see how we go, and we'll move on from that. A little bit about Nivomo. I don't know if you guys are familiar or heard about Nivomo, but Nivomo was formed exactly at the stage where you are. It was a student team coming out of Warsaw University that then set up, like Avishkar and like a few of the other teams here, and then started to grow itself, and it became Novomo in 2017. It was actually called Hyper Poland originally. But since then, it's grown. There's about 55, 60 staff now, based out of Warsaw, offices in Switzerland, Germany, and also out of Dubai, where I'm based as well. Saying that, we're also part of what Mars was saying, part of the European collective on developing Hyperloop. We're also funded through the European Union. So there is a commonality, and there's a thread that you'll see emerging from all of the companies now in terms of the ability to be able to collaborate, because I think without the collaboration, I think it's going to take a lot longer. And again, like I said, part of this is what I want to talk about today. A little bit about my background, unusual in the sense that I've spent nearly 30 years working in railways. And I also know there's a very strong railway presence here from Indian Railways. But from 95 was when my first railway project started, right the way through until 2016, when I actually joined Virgin Hyperloop as the CEO MD for the Middle East and India regions. I spent a lot of time working in railways, but when I was introduced to Hyperloop technology, I was convinced that this is the future of ultra-high-speed technology, and super exciting. And so what I've got here is a few snapshots and photographs of the career, and bearing in mind that all you guys are starting right at the beginning of your careers. I'm towards, I would say, the back end of my career now. But what I want to just is highlight where we are and what I've sort of done, the circle that I've come through. Started off in highways in the UK back in 1981. I moved on, went to work for the Ministry of Defence, and I was in the Ministry of Defence for 10 years. And that's where I started to get really involved with R&D and also in some of the military aerospace projects. And in 1991, I was the project manager responsible, and this is my claim to fame, for the R&D advanced test facility for the Trent 800 range of engines. Now, if most of you travel, you'll get on an airplane, you get on an Airbus, you'll get on a Boeing. Most of those engines are Trent 800s. And the significance of the Trent 800 engine was that it actually moved the airline industry, the aviation industry, from having long-range four-engine aircraft to long-range twin-engine aircraft. And the reason was that the Trent 800 was a step up in the power thrust that was being developed. We went from 60,000 on RB211 to 110,000 thrust. So that was the sort of introduction into aerospace back in 1991. 91 to 93, I remember it because it was actually one of the most high-pressure environments I worked in because we needed that test facility for the main production facility to kick in for Cathay Pacific. Moved into railway and transit in 1995. Moving on recently, I've spent the last, I would say, 12, 13 years in the Middle East. A lot of that time I was responsible and accountable for some of the largest metro projects and also delivering Etihad Rail Phase 1, which is the first heavy-haul railway in the United Arab Emirates. Like I said, I started to get introduced into Hyperloop 2016, and then I got convinced and I moved and I became the CMD in 2017. And since then, there was a huge amount of work that we actually progressed in those years from 2017 right the way through until, I think, in 2022. And unfortunately, I left in 2022, but unfortunately, the company actually closed in December 23. But there's a huge amount of work that's been done. And part of what I want to do today is give everybody an insight to the amount of work that was done here in India and to be able to work and leverage that work to the best effect. So India's Hyperloop journey. First of all, global Hyperloop competition. We actually, in 2016, were not sure where we wanted to go with our technology. No idea. So we actually do a sort of a reverse auction and went out to institutions, organizations, authorities, governments to ask them where technology like this could make best effect, add value. And what we found was, obviously, we got a lot of responses from the US, Europe, where you expect those responses. The one region, and the Middle East, and the one region we didn't was India. We had an outstanding response from the institutions here back in 2016 on the potential and the routes that Hyperloop technology could add value to. So we then started to look at that, and in the end, we decided as a business and a strategy that India was going to be a key core market for us. Having done that, we then actually launched our vision for India back in 2017. And if I go back, February 17, we had a big event, and that's where we started to really engage both center and start to look at states at the same time. And from some of that work that we did, we started to see some of the corridors that were emerging, some of the dense routes that we believed could add value. One of those was Mumbai-Chennai. 1,100 kilometers, 63 minutes versus 4.5 hours by air and 23 hours by rail. But it would have connected Mumbai straight away from the west coast to the east coast via Bangalore. Another route we looked at was actually Bangalore to Chennai as a key corridor. And then there was a bunch of routes that radiated out from Delhi. Some of those were Delhi, Amritsar, Delhi, Jaipur, and Agra. But what we needed to do was focus. So what we decided to do was focus on a particular route, and that was a section between Mumbai to Pune. 140-odd kilometers, 145 kilometers. Currently takes about 3.5 hours. I think most people will know that. But by Hyperloop technology, it was going to break that 2.5, 3 hours down to 25 minutes. So having started to sort of develop the Indian market, what we did very quickly, very early on, was signed agreements with Maharashtra, with AP, with Karnataka, Punjab, to start investigating some of these routes. And one of the states that really emerged and took a very proactive stance on this technology was Maharashtra, and predominantly driven by the Chief Minister. And again, I think you will see that what you need here are champions, both at federal level, but also at state level, to enable organizations to come here, invest the money, develop the technologies, develop the commercial routes. And so what we did was we signed an initial agreement in September 17, and then what we did was we signed a binding contract with the state of Maharashtra at the Magnetic Maharashtra Convergence 2018, where Richard Branson and a lot of the board and also the Honourable Prime Minister himself was there then. But that set the foundation on a partnership between the state and ourselves to develop this route, and also for us to invest money, allowing our investors to come on board. So the deal there was PMRDA, Pune Metropolitan Regional Development Authority, was to provide the right of way and assist with establishing the route. So they were going to be our POC on the ground. Project was split into 2 phases. We had a 12, 15-kilometer test facility that we were going to use, where we were going to work with Indian Railways. We were going to work with the principal scientific advisor and the various institutions to get the certification. And then what we were going to do was, on achieving that, move forward with the project into phase 2, which was going to be all debt equity funding. This project didn't require any public money whatsoever. This was a privately financed project, and we also, I had a bank guarantee from the parent company of our biggest investor and shareholder, DP World, to enable us to move on. Having said that, the project also was a very successful, or would have been a very successful, privately funded project. It was giving us an IRR of 23%. I think when we did the initial pre-feasibility study, it was about 30%. Again, what you'll do is, as you get into the detail and you start getting into the detailed feasibility, and then you get into the DPR, costs will only go one way, and they'll increase. So that sort of initial rate of return dropped down to about 23%. Annual passengers about 150 million. That would build up over the life of the project. But the big thing about projects like this and investments like this, it's not just about Hyperloop technology. It's actually about the ecosystem, the socio-economic impact that are generating. And that was valued. And by the way, the technical advisors, both on the government side and on our side, agreed this at $55 billion of socio-economic benefits over the lifetime of the concession. So the progress that was achieved And I just want to sort of capture this and sort of give you a flavor. Because we started, as I said, in 2016, February 17, Vision for India. That then followed very quickly where we signed an MOU to conduct a pre-feasibility study. That only took us about 6 weeks, by the way. It was very quick for us to find out whether this was going to be an investable project. We then moved on in February to sign a binding agreement. We then moved into the detailed feasibility study in March 18. DP World came on as a key core sponsor investor with us in 2018. They were already an investor in Virgin, but they actually came and invested and backed the project at that point, 2018. June 2018, Chief Minister of Maharashtra and the whole team came to visit us in the US at Vegas and toured our facility and our test site. We submitted a detailed feasibility in August of 18, and then in September 19, we were declared as the official OPP for the project. And then, what happens? Who would have guessed that the Chief Minister was no longer going to be the Chief Minister? And then politics comes to play, and we had a big change in direction at the time, and that then started to lose a lot of momentum on the project. And then after that, everybody knows India got locked down in March 2020. We got the pandemic. We weren't able to move around, and I think then we started to lose momentum. And the key thing here is to also understand investors. Investors have very, very short cycles that they would like to get a return on. So when we start getting projects that start slipping and start moving to the right, I think investors then start having a big part to play in this, and I think that started to also creep in. But the point is, we lost that momentum, we lost the investors, and we lost the ability to move on. So that project, there's a huge amount of work done. It's captured here in this slide. But it also allowed us to set up the high-powered committee that started to look into Hyperloop technology back in 2021, chaired by VK Saraswat. And we spent a huge amount of time, again, presenting the technology, presenting the timeline, presenting the business case to the committee at the time. And I left, like I said, in mid-22, and I think the report came out sometime in 22 on moving forward. But the report ultimately has enabled all of the audience here and IIT Madras to move forward, and for Indian Railways to now come on board as a key sponsor to enable this technology to move on. Having said that, I also think there is a different way of delivering some of the technology. Some of the lessons learned over the past sort of 7-8 years, I think, were trying to convince everyone of the technology and its maturity, and when would it be available, and when could we get returns. Has anybody been on it? Well, at Virgin in November 2020, we actually carried passengers in the full-scale Hyperloop project and in a demonstrator in November 2020. So yes, passengers have been carried. Yes, there is a full-scale test facility that we produced. We did over 450 tests. XP1, our first vehicle, went up to 387 kilometers in a half a kilometer full-scale test facility track. So a lot of work has been done, captured, it's there, and I'm sure that all of you guys here will be starting to springboard and leverage off a lot of what's being done today. Novomo, as I said, started in 2017 or 2016. 2017 formed the company, but it pivoted in 2018 to start looking at how some of the systems being developed in Hyperloop could be adopted for early use on existing rail transport systems. So this is the very interesting thing. So I want to say this because what I want to say is, if I'm a bit philosophical, I'm going to go a bit philosophical here. If we look at the world that we live in, we have a world of the haves and the have-nots, right? And the haves are, one would say, are Western, developed economies, rich economies, great transportation, rail, high-speed rail, metro, have it all. Then you've got countries that are developing, that have some systems, but need to develop them. Then you have those developing emerging economies that don't have the infrastructure, but are felt threatened, not threatened, throttled, because they have the potential. Some of the technologies there are emerging, but some of them are already there to enable things to move. And I'll give you an example. Just look at Africa right now. Yeah? Africa, large parts of Africa have very advanced telecommunications, very advanced banking systems, right? But they still don't have access to e-commerce. Why can't you have access to e-commerce? Because you don't have the transportation, the ports, the railways, the infrastructure that's needed to provide safe, secure delivery end-to-end, right? But if we then start looking at the technologies that are available to us now, like Hyperloop technology, like eVTOL, then you start looking at drones and last-mile deliveries, electric vehicles. If you start looking how in the next 5 years, all of those mobility solutions will start coming together, then you can have almost what India did in telecommunications, where it leapfrogged landlines and hard infrastructure into the digital era. Transport and technology could enable emerging economies that need that infrastructure to leapfrog again once more. But more importantly, let's talk about the countries that do have. And I would say India is a country that has. It has a lot. It has 67,000 kilometers of railways, right? Now, I apologize for the slides, but these were taken straight from the National Rail Plan. So this is the best I could get. But all I want to say is just that. I'm going to go back. 2026. This is where we are right now in terms of utilization of the railways, right? If we don't do anything to the Indian Railways, this is where we're going to be now by 2051. And these are not my figures. These are Indian Railways' own figures, okay? So innovation and technology has a huge part to play as we move forward in India in resolving some of the transportation, cargo, and logistics issues that are here and need to be tackled. So how are we going to do some of that? Well, as a Hyperloop company, our end goal is still ultra-high-speed transport. But what we're saying and what we're doing is looking at some of those advanced technologies and bringing them to the market sooner. So you can see here the middle portion, the sweet spot, is what we're aiming for, which enables us to demonstrate a lot of the subsystems and systems that will be required ultimately in Hyperloop to be brought to the market, to enable them to mature, to enable them to generate revenue, and to enable us to actually move forward to the ultimate goal, which is that Hyperloop vacuum rail travel of the future. So in terms of our technology and our progress to date, what I'm going to do is play a video here. So what you saw there was some of the technology being explained in terms of how we're going to adopt it for introduction into existing standard gauge railways, both from a propulsion perspective, but also from a levitation. So we have introduced, not only introduced technology, we've also now a full-scale proof of concept, 750-meter test facility in southern Poland, where we've now shown that you can actually levitate existing rail bogies on existing track, but you can also move standard freight wagons remotely, autonomously, using the linear synchro motors that we've developed. And that is so important, I think, as we go forward, Because what that enables us to do is to start targeting some of the cargo and logistics markets and audiences that really need the additional capacity building out within them. Now, I'll say that because that becomes even more important when you look at the geopolitics that are coming into play, because November was a very big part. In fact, here at IIT Madras, it was the G20 summit, and the key thing that came out of the G20 summit was IMEC. That was the India, Middle East, Europe trade corridor. And that trade corridor, right, is an alternative to the Belt and Road Initiative, which all of the G20 agreed needs to be implemented. But in order to do that, you need to get the rail, the ports, intermodal facilities, the countries, all integrated. So what you've got to do, and I think I will leave this with you, is get more for less. So the technologies that we're now looking at, what Novomo is doing, is enabling you to get that ability to generate more capacity, more efficiency, yeah? To be able to use and sweat the asset more, rather than build more infrastructure or build your way out of it, which has traditionally been what's happening. So innovation and technology has a key role to play in the next 5 to 10 years to enable that G20 vision to be met in its entirety. And I'll give you another example. I'll give you, a fact here. Does anybody know what the TEU, or the container capacity for India is? Total? I'll tell you. 19.71 million TEUs per annum. Right? For all of India. Do you know what the capacity is of Jebel Ali? 19 million. One port in the Middle East has got the total capacity of India. So India, to be able it to actually hit its growth capability, its growth capacity, needs to be able to transfer from highways, 75%, move it onto rail infrastructure, move it through its ports, to enable it to actually keep pace with its economic targets for growth, as envisioned by the leadership here. So, going back to the test, this is a Photoshop. That's a standard bogie levitated off existing railways. Managed to get we got a 20 millimeter gap there. We got up to 130 kilometers an hour, like I said, on a 450 meter test facility. Levitation speed started at around 70. It's like actually 720 meter length test facility. And it was a near 4 vehicle that we were using. So that was done in September 23. Last week was also a groundbreaking opportunity for us because we formalized and announced our collaboration with the Institute of Hyperloop Technology in Germany, which is part of the University of Science and Technology at Emden. And the key there is, and I think Mars is starting to lead to it, I think Tutor are starting to do the same, the ability to be able to look at organizations around the globe and see how we can actually maximize and bring them together. What I didn't say about my career, I'm also an advisor to Airbus, and I'm going to use the Airbus analogy. Airbus do it very, very well. What they do is look at what the market is and then bring it all together into a product that can actually come to market quickly, efficiently, and deliver. So what we've done is, in fact, the Institute of Hyperloop Technology has agreed, and we've agreed to let our propulsion systems, control systems, power electronics, and some of the embedded turnkey solutions to them to enable them to move quicker and faster. So I'm going to sort of go towards the end of my presentation before I'll take a few questions. Opportunities. I think there's 3 key areas as we move forward in the industry, having spent sort of best part of 7 or 8 years. Industry collaboration. I think Mars is alluding to it. We need convergence as soon as we can on the technologies that are available, because that will drive down costs. That will enable us to actually move forward faster in terms of time to market. But that really is one for the industry to address. And I think what's happening in Europe, and I think the latest call where I think there's a bit of a partnership being formed together, I think is very, very important. I think the same will probably happen in India, which I've been advocating for a long time. Okay? I think governments have a huge role to play. Identification, supporting the technology. When we were working with the high-powered committee here, when we were working with NITI Aayog, principal scientific advisor here, there's only 3 things I wanted. 3. I didn't want them to approve the technology. I didn't want them to endorse the technology. I didn't want any money. What I wanted was for the government here to recognize that Hyperloop technology has a key future role in the transportation solution to India. That would have actually, and that will make a big, I would say, impression, certainly when it comes to investors and raising funding, number 1. Second thing was, I think it's great Indian Railways are now taking the lead from a federal perspective in terms of the technology and technology oversight and development. At that time, we didn't have anyone. I wanted a nodal point of contact, a nodal agency that we could all go to that would then collaborate with the various other agencies. And then finally, what I wanted was the state government, 3 things. Because if those 2 things fell in place, the state government was going to fall in place. And the state government to actually come forward and agree, well, actually it was federal state, agree on some of the policies that we needed with respect to the privately financed initiative project that we were running. And that included regulation around fares, regulations around GST, etc. So there's a few things on the policy side, and those 2 other things that I mentioned. Suppliers and operators. I think suppliers, operators, OEMs have a huge role to play. They need to embrace the technology. We've got huge organizations here in India. And I think if they would embrace the technology, work with us, come forward, I think they could shape the ecosystem as we move forward. Recognize that Hyperloop isn't a threat. We're actually part of the future for them. And I think that would also improve the relationships and also encourage them to come forward and capture the benefits. So having said all of that, I'm going to leave you with this. Famous Lord Kelvin's statement, heavier there, flying machines, impossible. And then what happens? We get flight and the Wright brothers. So I think that, I'm running out of time. I think that was the presentation. Thank you very much for your attention. And a couple of questions. Have we got time for those?
Yes.
Yeah? Perfect. So there's a couple of questions, and then we can answer those. You want to take one of these mics?
Anyone have any questions to ask?
I have a question. So, hi sir, I'm Sriraj from IIT Madras. So I've seen the presentation, it's so informative, thank you for that. And I'm particularly interested in the collaborations that have been made with the PMRDA and the government of Maharashtra for developing the Mumbai-Pune corridor. So I wanted to ask, whenever we're speaking about bringing this technology into real life, bringing it to people, government, the involvement of government is actually needed. So what policies from the government side do you think need to be learned about to bring this project to a success? Thank you.
Okay, I think I alluded to that right at the end of my talk. I think it depends on the procurement structure that you're using, okay? But the procurement structure that we were using was private money. And private money needs surety, yeah? It needs surety on fares, fare regulation. If we had invested $10 billion, which was the cost of the overall project, what we needed was the ability to ensure that we could control fares, and fares weren't being regulated, which they are at the moment. For public transport, fares are regulated. That regulation wasn't going to be in line with the financial models that we were using. So we needed to have freedom and flexibility on fares. So that gives you a key example of the sort of policies that we needed amending. GST tax. Yes. GST on a 10 billion project is huge. Yeah? So we wanted to be able to, and certainly on nascent technology, on technology where we're investing all of our money, risk, and then we wanted some kind of relaxation on the taxation, both state and federal. That would also help to enable us to fund the cash flow in the project. So those two things were fundamental at the time. Land was another one. Yeah, we were very we had a very novel sort of approach to land. Land was going to be granted by government. We followed the expressway for most of the route. I think we were talking earlier on. I think we had some friends here. We weren't going in straight lines. If the Mumbai-Pune Hyperloop route was a straight line, we could have done that in 14 minutes. The fact that it was 25 was the reason that it's 25 was that we followed the expressway for most of the corridor until we got to Wakra, where we went then online and then tied up Purple Line. Okay?
Yes, that's also a question. Thank you, sir.
Hello, I am from Railways. Why you made a presentation which you explained the reason why Pune-Mumbai could not take off. What I wanted to know is that why has Virgin Hyperloop now checked out of this? And now many of the things that were moving towards passenger traffic in Hyperloop is now more oriented towards the freight oriented Hyperloops. So why did Virgin Hyperloop checked out of this from the Hyperloop itself? And why there is more caution in going for a passenger Hyperloop across the world? Even the South Middle East Hyperloop project is also not taking off, I am told.
I think a lot of these are a lot of these are politically driven. The Virgin, as I said, sort of very openly in the presentation, we were working on the Mumbai-Pune route since 2017. It was 2019 when we became the official project proponent, just to get the EOPP. So there is a need for government, state, but also the private sector to integrate much better, and that was a key lesson learned. Okay. We then had issues around the pandemic. We had a political intervention. The government changed in Maharashtra. So you then had a coalition. And then the ability to be able to make that a priority. So priorities change. So that's where I think having federal move into and by the way, the projects, I think you mentioned the need to have a Hyperloop network, a policy and a vision and a statement that Hyperloop has a key role alongside high-speed rail, alongside standard rail. That is very important, and that wasn't there. So, no, at the end of the day, the investors started to lose a bit of interest, and like I said, they have 3 to 5 year cycles. Politics came into play. So a lot of things, anything that could happen, happened. Pandemic came. We couldn't travel.
Sir, I understood very well why the project of Mumbai-Pune has not taken off. But apart from that, Virgin Hyperloop has now almost checked out of the business. Globally, they are not working on Hyperloop, it's understood. Yeah. Any reason for that? That's what I want.
Well, I mean, I left in 22, so I can't answer for Virgin Hyperloop why they decided to move out of the business in December 23. So all I can say is that there was a lot of differing opinions in the way the business should go. I can't comment on that. I don't want to comment on that. Ultimately, it was a company that was funded very, very heavily, very strongly. It was very committed to India. But yeah, the board made a decision that they wanted to move on. I think there is a fine line when you come to technology, you come to investment. There is a window. There's a window of opportunity that you're working in. And I think sometimes, I don't think audiences realize the amount of pressure and the expectation that investors have and what role they play in this. These cannot be, if you cannot close the deal, in 3 years, then investors need to understand where they need to move the money next. So, and if you lose your investors, you then lose the momentum and the credibility in terms of moving the project forward. Okay? Okay, well, I think that's the questions and answers. That's the presentation. Thank you very much. And I'm still going to be around if anybody wants to come up to me. Thank you.
Thank you, sir. That comes to the end of our morning session. It's time to refuel ourselves. I request the volunteers to guide the delegates to our dining area, and reminding people request to remain seated. Welcome back, everyone. I request everybody to remain seated so we can start our afternoon session. Our afternoon session kicks off with an insight from industry leaders and policy makers, shedding light on the trends on advancement and shaping our future. Our first speaker, I welcome Mr. Sheetal Kumar Joshi, Senior Director, ANSYS, India, to share a few words. Please come to the stage, sir.
Thank you. Yeah, good afternoon all, and it's very privilege to kind of address all of you on this important gathering, and thank you for hosting and for this conference and allowing us to kind of participate. So what in next 10-15 minutes, what I would like to do is share some technology trends, may not be exactly on Hyperloop technologies, but the technology trends on virtualization simulation across the industry that we are seeing, which many of them would be quite easy for you to adopt in your product design and testing and validation processes. I'm sure some of this you are already using it, but let me just, with that note, let me get started. Just finishing my custom over here, introducing ANSYS before we start. Most of you know we have been kind of in simulation for about 50 years. Over the last 15 years, we started acquiring many technology, and that was a more strategic decision to have the complete multi-physics interactive, not just kind of single physics design, but design development, verification, validation platform. And this shows our list of acquisitions, that 29 acquisition, and probably I could say that over the years of experience, ANSYS has done good job in combining the various company, integrating various companies' technology. And of course, people and culture combination is also challenging, but I think that has gone quite well, resulting in the new technology suites that's coming up, and I'm going to talk about that shortly. So this is quickly about products. We have kind of product can be a multi-layer products. core physics products that appears of the fluid dynamics, structural, optical, semiconductor, and so on. On top of that, as we are combining the products, like we are integrating on a single platform that can work together. And of course, we are also going on developing our ecosystem, which one of the slides I will touch base as well. On Hyperloop systems, I think I would not need to explain you the applications where simulations are being used. This is pretty much kind of all of you have been doing day and night, the set of applications. So I will not touch base on these applications in my next few slides. I would like to just mention one note over here that ANSYS globally has been quite active on working with the startups in the domain of Hyperloops. And in fact, my title slide was picture from Tutor that our teams in Germany are working with you guys. So yes, so we are kind of hoping to continue that association to make this dream a success. So let me go forward now. This slide talks about, this is kind of a basis of my next 10 minutes discussion. This is ANSYS focus for next 3 to 5 years. This is not just ANSYS focus, I would say. Majority of technology companies are focusing on these areas as well. And we'll touch base on each of them, what is being done by ANSYS, what industry is doing. Let me start with the first one. First one is the core numerics. Core numerics and the physics is our bread and butter. This is where ANSYS is known for the high fidelity numerical solver across the physics. So we continue to invest on this part. The major investment areas are coming up with the higher order numerical algorithm, being able to model more and more complex domains as we move forward. Also integrating machine learning. Some of the technologies, very advanced technologies like mesh fusion, which allows especially electronics assemblies of the several components starting from chip to system. So those sort of enhancements are ongoing, and you would hear about them in every product release. What are those? I would just kind of give a glimpse. One of our important area where the industry is moving is the high frequency semiconductor, and HFSS is by far the gold standard in this. But last 5 years, if you can see last 5 to 10 years, the computation possible through this HFSS has exponentially grown. So what semiconductor companies at a chip level, micro, nano level, they would like to do electromagnetic modeling, that is becoming possible rapidly. And this scale up is probably faster than Moore's law, I would say. So the basic algorithm development that we are doing, that has been kind of pretty strong. Second pillar is going to be our GPU. We are investing more on any means we can do to increase the speed of simulations. Now, speed of simulations would mean that our users, our organizations adopting our solutions would be doing much more simulations. So design of experiment, DOE space increases. So ANSYS Fluent, those of you who are familiar, we have rewritten this code. This is I would say, legendary CFD code, which introduced like non-structured meshes in the industry first and all, quite popular. But now we have rewritten the entire code to be able to kind of scale for GPU. So now we have that new solver available. 4 GPU can do better job than 1,000 core CPU cluster. So that's the benchmark that we have set now with the new solver. Specifically, aerodynamics. I know it's a low pressure aerodynamics for pods. I think this can be extremely fast for Hyperloop calculations, such kind of solver enhancements. So on GPU, we have all of our products are slowly moving to GPUs because of the infinite compute capacity that's available on a single GPU, put on the cloud, and the set of the clouds cloud offering that's available on GPU now. So that's where industry is moving, and we are aligning ourselves. Third part, which is artificial intelligence. Pretty much every organization on this planet has some strategy related to artificial intelligence. So does ANSYS. Now, if you understand numerical simulations, they are deterministic simulations solved from the Navier-Stokes equations, Maxwell equations, whereas artificial intelligence is more of data-driven thing. So how does this two combine? And probably if you asked me 5 years back, I would say these two are exclusive. But now there has been technology in kind of that has been developed to combine these two, which ANSYS has integrated, is physics-derived machine learning. Now, why this is important is typical machine learning algorithms or model that we have on the commercial domain for our consumer experience and all, they would have hundreds, thousands, millions of data available. And there we can, through deep learning, you can create the model. But for engineering community, for product design, if you can get 100 data, you are one of the good, lucky people to get 100 set of data. So how do we solve the problem to apply the machine learning utility where the data are very sparse? So this is being done by what is called as physics-derived neural networks. So that drastically reduces the amount of the number of data that is required, but it also has some multiple other advantages that I'll show you one of the examples. So that is the direction that we are moving. There is one more set of direction, what we call is bottom-up and top-down. What I mentioned is top-down, but bottom-up is a solver level, equation level incorporation of neural networks. That is in R&D, and probably we will start seeing the product in a year or two around solver level neural networks. But let me show you what it is happening now today. So for an example, if you are having kind of electric propulsion you are having, and if you would like to characterize the entire electric motor to be able to carry out the virtual system integration of the entire pod on like 1 kilometer track or whatever that scenario that you have, you would require exact definitions of your motor. If you have motor geometry, design data, that's great, but still you would need to carry out some experiment because the simulations will miss out the details of some material, some data which is coming from supplier, some operating condition here and there. So companies will need to carry out bench test. Now, one of the use cases of machine learning over here, and this is being done quite a lot in EV industry in India, because EV industry in India, when the companies are moving, they are starting with the electric motor sourced from the supplier. That's a business decision, of course. But if you need to truly integrate in a virtual model, full model, they would need to do bench test with about 700 points. That takes 6 to 8 weeks on a dyno test. Extremely expensive process. Now here machine learning comes to rescue. Create a physics-derived model, and on the bench test, you will need only 50 to 80 data. I have written 100 over here, but all our tests are says 50 to 80 data are that's it you require. So the testing need decreases drastically from 700 points to 50 to 70 points, 6 to 8 weeks to 1 week. And this is the technology that is available. Automotive company in India, including startups, are deploying this already. So that's the one part. Second part is on machine learning is the full field level machine learning. And in this quarter, ANSYS announced a product named SimAI. It is a web-based product. And I've been in simulation industry for about 25 years, and I can safely say that this kind of technology is going to transform the way all of us are going to do simulation in day-to-day manner. Now, what the SimAI does is it provides a field view of any data that you may have generated from simulations or from test data, even though it's just showing the simulation, but your test data can also be uploaded. Again, I'm repeating, this is the field data, not a scalar variable. This can be kind of trained through physics-derived neural network, and as you can see, after that, your assets get created for a given vehicle for the operating envelope. What organizations are starting to do is they are creating those digital assets, especially those who have multiple components, business supplying kind of many models. They are creating individual asset for one model. Now, any changes that anyone want to do, over here, this example is showing just for external aerodynamics, but these changes would be done within seconds. So this will become an online set of asset. I have shown over here CFD fluid dynamics, but this model is physics type independent. Be it electromagnetic, be it optical, be it fluid dynamics, thermal, structural, all sort of solvers would be working over here. So watch out for this. This is a this release is being happening in a staged manner. So it should be soon available to broader set of usage. So this is about machine learning. Let me, So I kind of created a video. I'm not a fan of videos, but this helped me to explain the point that I would like to mention, that on finance domain and pretty much all domain we have seen you can see AWS hosted simulation solvers. Okay. Now cloud has not been kind of as popular on the simulation engineering domain as opposed to kind of many sensitive financial data are there on the cloud, but that's changing now. Organizations would want to their product design data they are comfortable putting on cloud and take advantage of the elastic unlimited capacity that is available. So ANSYS is also getting ready. We have AWS, Azure got created, and the entire work environment, either you are doing it from mobile or from web browser or connected to your computer or connecting to local sessions, pretty much all seamlessly is getting done. Now, connect this with the earlier machine learning and GPU. So you see the multiplier effect or the way kind of computation is increasing and the technology is merging together. So that's another trend that we are observing. And last one I would like to mention, which would be pretty much relevant for virtual system integration, is digital transformation. Let me skip through this slide. But the idea is in digital engineering, you would like to connect, like in the physical system integrations where your component which are getting manufactured by prototypes or supplier and you would integrate and test it. In virtual system also you would like to do. That's the dream that everyone has. Can you integrate individual component in the virtual system? Now what was missing over the years was a high quality definition of the model of individual components. Because certain components probably you are designing in-house. CFD simulation, FEA simulation will take 1 day, 2 days, 5 days. That cannot be used for system simulation. System simulations would require us to do things in minutes. So all earlier practices that I mentioned, through machine learning, you can now create a transfer function which is fast executable, as accurate as 3D. That's number one. Number two, if there is a lack of data, you can use machine learning and certain small set of test data to make the component definition further accurate. That's number two. Number three, the tools that are available. ANSYS has Twin Builder or MathWorks or anything. Doesn't matter which tool kind of you use. But these models are largely interoperable across the tool chains. So once these things are available, as you can see one example which ANSYS has been quietly active on, that we start with the core physics simulations of the sensors, radars, pretty much, I think some pictures are not coming clearly over here, but all the sensor models are physics-based model. Physics-based model transfer functions gets created. They are fed to driving simulators, including hill system, and the entire scenario, whether you're driving in night or daytime or radar or corner cases, pretty much everything can be simulated. So this is what also kind of industrialized, I would say, productionized to have a large-scale cloud-based deployment of the entire system simulations. Now I can easily see the correlations of this with your test tracks that you are building. Key thing is going to get the key component models for such kind of methodology, but this methodology is available at your disposal today. So the last part is I wanted to mention about the Pi ANSYS. That is what is also changing, especially for academic and startup community. You're kind of Python geeks, so ANSYS has opened all our APIs. We are spending a huge amount of R&D effort for last 2 years on Pi ANSYS. This is for our commitment to open source, where libraries can be available online. GitHub libraries are there. So automation is going to drive the way efficiency that you would like to get. So those who are kind of interested in Python, I think this is something that you would look for, where the industry is moving rapidly. So these are the 5 pillars that I mentioned we see in industry, as well as ANSYS, that what we are investing in this various technology. On closing note, I just want to say a couple of topics. ANSYS has a very strong academic program. These numbers that appears over here about the universities and courses. On India, I can say Abhimanyu is kind of leading that. We have trained about 40,000 students across our direct as well as our network of channel partners. 2,000 faculty trainings has been done, and NPTEL courses are also now, we have collaborated having MOU. Our objective is to make sure, find the scalable way to deploy the knowledge available to a student as much as possible. Besides that, of course, with SA India and many collaborations that we are doing for the student community. And the second one is the startup community. ANSYS has a very strong, solid startup program for several years. Some of the very known startups like SpaceX and of course, we also worked with QE and all. They are kind of part of our program. Through this program, we provide licenses, but for select startup, few of our engineers are also get associated in advisory mode. And in this kind of conference, I see that many startups are there. Reach out to your kind of nearest ANSYS contact, and we'll be happy to kind of provide support that's required. So with that, sorry, I may have taken 5 minutes extra, but I hope that you got a clarity about the industry technology trends, many of them that you can adopt in your Hyperloop system integration validation. Thank you. I'm around for till evening. So if any discussion required, I'll be around. Thank you very much.
Thank you, Mr. Joshi. Now I request our next speaker, Ms. Koneru Bhavani, Executive Vice President of L&T, to come to the stage.
Thank you. Good afternoon, almost the entire Hyperloop community over here from India and overseas. I'm represented from L&T along with my colleague Mr. Ashok, who is over here, who has been working with most of the Hyperloop technology providers from across the globe for quite some time. We from L&T, as many of you are aware, maybe some of you who doesn't know, we have been in this construction industry for past 80 years, and L&T has been pioneering in the technology. Whichever new technology is there, yes, we are the first to implement and adopt and support the academicians as well as the new technology partners. Just to have a glimpse at our organization, what we can do, I would like to show our corporate film.
The future is closer than we think. Using digital technologies, we're implementing futuristic solutions to make quantum improvements across all our businesses, resulting in smart engineering, smart manufacturing, smart project management, smart infrastructure. Our proven global expertise in infotech, as well as technology services, enables us to solve complex business problems at the convergence of the physical and digital worlds, both internally and for major clients across the globe, including a large number of Fortune 500 companies. Disruptive technologies like the Internet of Things are changing the way we live and work. We are leveraging our rich engineering heritage with these new technologies to offer businesses worldwide services that enhance efficiency and productivity. By exploiting analytics for innovation, we are transforming the way these industries operate. Cities are the beating heart of the world's economy. Their speed and scale of expansion presents a choice: mega-city turmoil or an inviting urban environment. A smart city. A smart city involves the application of information-based systems for better governance and services. With expertise in both infrastructure and new-age technologies, L&T has the edge in implementing India's mission to make 100 cities resident-friendly and sustainable. Every day we help light up hundreds of villages and power businesses and industry. We provide a complete range of solutions for power plants, from concept to commissioning. Our heavy engineering facilities are among the largest and best equipped in the world. They fabricate complex large-size equipment for core industries and provide critical equipment for India's nuclear power plants. We are the only company with the capacity to build an entire nuclear power plant on its own. Nuclear fusion has the potential to replace every other source of energy. Larsen & Toubro is collaborating on a global project to build the world's first thermonuclear reactor in southern France, a potential step towards an abundance of energy that could power the planet for millions of years. Till such time alternative energy sources reach full maturity, hydrocarbons remain the principal source of the world's energy supply. Our presence spans the entire hydrocarbon value chain, from exploration to refining to erecting complete plants. Through products derived from hydrocarbons, we touch your life every day. In a myriad other ways, we are a recurring presence in your life, day after day. Moving you through airports built by us, over bridges, roads and intersections that we have constructed, through state-of-the-art metros that we have built. And as you arrive at your destination, an array of properties await you, built by us to the highest standards. Whether it is the tallest, longest, largest, we at L&T have built it. We apply technology to man's most precious resource, water. Our ability to build a world-class water infrastructure covers all aspects of treatment and conservation, including desalination. Strength is a prerequisite for peace. It has been a mission with us to secure your way of life by helping strengthen the country's defenses. Through intensive investment on research, we developed a system of systems capability, enabling us to build complete weapons platforms, including India's first nuclear submarine, a long-held dream. The Indian Navy looks to us for an entire range of weapon systems, and the land forces for diverse advanced weaponry. Given the trust built over decades of proven performance, we are well positioned to be the leaders in India's defense expansion. We have played our part in India's mission to the moon and its thrust to orbit Mars. For decades, we have made critical aerospace components for the country's space program. Through our technology leadership, we now have the capability to build complete launch systems to place satellites into orbit, opening up limitless possibilities for the future. Technology is pushing from every direction. The future doesn't belong to the faint-hearted. It belongs to the resolute. It belongs to those who strive, who seek, and do not yield. The future belongs to the brave.
There's a small introduction about our organization. Yes, it's very true. Future belongs to the brave. I think who else can say other than all of you who is working here on the future mode of transportation. And from the beginning of the mankind, the connecting people and connecting places have become a biggest challenge for entire whole world to develop. And when we are talking about Hyperloop today, this is a new era in transportation where we are able to connect the people. We will be able to connect the people across the globe in the years to come in the shortest possible time, where the speed is becoming the essence today for the entire world. And imagine the future where distances are going to shrink drastically and where we'll be able to connect people and transport goods in the shortest possible time. I think we'll be able to eliminate the poverty in the whole world with the development of Hyperloop technology, wherein we'll be able to provide the food facilities and healthcare facilities and the water facilities to all the people who are starving for that today. And right from the beginning in the 19th century, where we have started connecting within a local cities, local railways using railways, and then to the airports where it has developed in the 20th century, and the mobility has become a biggest advancement, and in the 21st century has seen the digital transformation. And combination of all these technologies together, I think going forward, the Hyperloop is going to be the biggest transformation which the entire globe has seen. And this, due to the impact of Hyperloop, we strongly feel that from the Larsen & Toubro, from our organization, it's very much possible for us to connect transport the goods and connect the entire market and create a lot of job opportunities. We'll be able to transport the people from one country to the other country and transport goods and able to entire world will be connected such a way that skilled people will be able to get the jobs wherever we are able to sustainable economic growth is what we are looking for. Transportation must weigh against not only on this connecting people, also on the environmental part of it. As an organization, we have a target for becoming carbon neutral by 2030 and water neutral by 2040. And this sustainable development of transportation is possible only when we have the green mobility of transportation. And this green mobility is possible, the high-speed trains which have started. We have seen the entire world from railways to high-speed. The gestation period, what it has taken for the development and the initial development to the final implementation, it has taken almost 30, 40 years. But today when you see this Hyperloop technology, I'm happy to see that India along with the other countries are going to work together and implementation is going to be much faster in India compared to all other countries as well. Why L&T is interested in this particular Hyperloop technology is, L&T is already present in 53 countries as of today. And we are also focusing on the research and development, and wherein we would like to transform the world and transform the country and to make it as a global transportation revolution. As a leader in technology, L&T recognizes the potential of Hyperloop to be more than just a transport mode. For us, it represents the opportunities to lead the change in infrastructure revolution as the technology will necessitate. L&T's interview in Hyperloop technology stems from our dedication to tackling some of today's most pressing challenges: urban congestion, environmental sustainability, and logistics inefficiencies. Hyperloop dovetails our strategic initiatives, offering not just a business opportunity, but a chance to spearhead a sustainable technological revolution in the global transportation systems. As you see, as a logistics industry, whole world is spending about less than 5 to 6% of their GDP is in the logistics. When it comes to India, it is already in 12 to 14% is the money being spent in logistics. I think this Hyperloop is through our Prime Minister's initiative of Gatisekti. It's not only for the people mobility, it can also be used for the logistics part, wherein waterways is not the biggest way of transportation of goods in India. I think this Hyperloop can be a game changer in Indian logistics sector, wherein we have a target to become single digit in terms of our GDP spend. At L&T, our mission is not only to participate in the projects, but to drive innovation and lead by example in adopting the new technologies. Our interest in Hyperloop technology is driven by several factors of innovation in our leadership. As you must have already known, the first high-speed train in India started just after COVID in 2020. And when we did not have any equipment to even how to construct this first India's high-speed, we have on ourselves taken up this entire equipment manufacturing. Although we have never done it in the past, we have just completed the design within a span of 4 to 5 months, and then we have manufactured the equipment in Chennai, in Tamil Nadu, just 25 kilometers away from here. And today we are able to successfully complete the equipment manufacturing and also construction of the high speed. Today I'm proud to say that we have completed more than 100 kilometers of high speed within a span of 3 years. Possibly this will be the world's fastest completed high speed once it is completed. So that is the technology and that is a commitment to what we have as an organization. We are there for all the new technologies. Whoever is ready to come invest in the technology, we are ready to partner with you, and we are there to give a solution to work along for the implementation part of it. Every idea is great, new ideas are welcome, but no idea is good enough if the implementation is not done, if it remains only on paper, right? But as an organization, it's our commitment to the society that yes, we are there. Any technology which is adoptable, implementable, we are ready to work not only in the technology development, also for the implementation of the technology as well. This is what is our leadership believes in, and as an organization, this can be a contribution from our end to the society. And to achieve this one, we have developed a huge amount of engineering capability within the organization. Today, we have almost 58,000 engineering professionals who are working in the organization in various fields, right from civil engineering to mechanical to hydraulics to digitalization to smart technologies. You name any technology, yes, we are there from different branches of L&T or different companies of L&T, right from L&T Construction to L&T Technology Services to LTI Mindtree Digital Solutions, wherein we'll be able to provide. As I mentioned, yes, sustainability is core of our organization, and we are ranked in ENR ranking, global number 3 is our company's position in terms of sustainability. And L&T wanted to become, in addition to becoming carbon neutral and water neutral by 2030 and 40, in the coming years, next 5 years, our journey is to become a technology company. And as a result of this, we have already taken a number of initiatives to start our L&T green energy, and we have already started entering into data center business. And we are also into semiconductor design, which we have recently taken up, and also to provide the education to the whole of the country and improve the skill set. We have started L&T EduTech as an initiative online platform where we are able to rope in with multiple domestic and international universities and provide that kind of education and skill set, not only to the professionals, also to the workmen who are there across, and we are developing them. And the challenges and how L&T wanted to face them, address them in terms of Hyperloop technology is by navigating all this, yes, maze of challenges is not going to be easy, but yes, we are ready to spend time and energy and ready to provide our engineers work along with the solutions. We are ready to do the POCs. You all must have seen, visited yesterday, the 400-meter track, which is being done over here. Yes, that did not happen overnight. Actually, our people have roped in with our Hazira manufacturing facility, which is possibly the only second or third nuclear reactor A grade by American Nuclear Institute, who have graded us. So that is a kind of technology, and with our engineers have worked day in and day out to find out how to do the welding and how to achieve the required tolerances and how to get the vacuum drop pressure testing. They all have worked in, and yes, we have ensured that it is required, and it also gives a confidence to our own engineers, and we'll be able to attract the best of the talent from across the globe to come and work with us, because this is what we believe in, that when we are able to work for the new technologies and contribute to the society, and we are there to implement and give that kind of a comfort level for all the youngsters and all the startups across the globe who is ready to come and invest. Yes, we are there as a partner to work with you, not as your contractor or not as your associate to work. Yes, we are there to work as a partner, taking your project as our project. Yes, we will be there in that. That is how we wanted to navigate these challenges. I know it's not going to be easy, but yes, if it is not easy, if it is not difficult, why we are there? Wherever, yes, there are difficulties, challenges, we are there as an organization to come and work. And with this, I would like to end my note and congratulate all of you. I have seen a lot of college students participating and with a lot of young, bright minds. We will together, I'm sure, achieve in maybe 1 or 2 years should be the target. That's what I was telling to some of them. If 3 to 5 years is the target for us to implement Hyperloop, they may be, today we are talking about the speed. There may be more technologies which are going to come up. Already one new technology which is coming up for improving the turnaround time of the ports. If that is going to take the leap, then we'll be missing the bus in terms of the goods transportation using Hyperloop. I think 1 or 2 years is the timeline we should work together. I'm sure we'll achieve, if not 2 years, at least 2.5 years to implement that, first goods and then slowly scaling up to the passenger. Or it can be other way around, even to start with the passenger movement itself. We are there to work, and I wish all of you all the best. Thank you.
Thank you, Ms. Bhavani. Our next speaker is through online. I welcome Mr. Pinaki Chobal, CTO of ArcelorMittal, share a few words about the same. Mr. Pinaki, you can start.
Hey, thank you. And good afternoon, everyone, and thank you for the opportunity to share a few thoughts here. I wish I was able to be there in person, but my colleague, Mr. Naresh Sharma, who heads our Engineering and Design Center in India, is there with you, and I'm sure you'll have a good opportunity to interact with him. I would like to share first a few words about ArcelorMittal. We are one of the largest steel producers in the world. We are the most global steel producer. And in terms of the mobility industry, especially automotive, we are the largest producer of steel solutions. And I want to highlight the word steel solutions because it goes to the core of how we want to develop the application of steels in the mobility industry. We are also involved in providing solutions for transportation in pipes and tubes. So when you look at all the areas where we have customers and we have steel solutions, they all finally combine together to provide the support that's necessary for what all of you in the audience here are doing, the tube transport, the Hyperloop technology. Now, I hope that many of you had a chance to see the test track yesterday. And I believe that the test track's a little too high for you to touch the steels that have been brought forward. But that is really what is the way we decided to join hands with IT Madras and with Tutor. Now, philosophically, the way ArcelorMittal would like to work is from very early design stages, because what we are able to bring forward or bring to the customers is the concepts that are necessary to bring in steel solutions into an effective and optimal design. So over the last 30, 35 years, in fact, we have worked very, very closely with all our customers, be them in the automotive industry, be them in the rail industry, whether they are in even ocean going transportation. So whenever we're talking about transportation, this is an area where we are involved quite in detail. Now, Hyperloop, of course, there's been a lot of excitement all around the world for the last probably 15 years. And from very early on, we have been involved with many of the early Hyperloop startups, looking and bringing our expertise to try to see how steel solutions can help move the needle. When I say move the needle, I mean move the technology development. And as the previous speakers said, that while there is the science and technology, there is also the implementation part. And this is the key reason why we were interested in the project that you were able to see yesterday. Now, just a question of how we got interested, and the story I think is a little bit interesting because we have been following the Elon Musk sponsored competitions, and for sure in the student-led part of it, we have seen how Avishkar at IIT Madras has come to the fore. I happened to be on campus and a chance meeting with Professor Satya. It was not planned. where he explained on his tabletop some of the core ideas and the core concepts of how using the infrastructure, the ecosystem, the concepts of what is required in India would allow a new or a different way of developing and commercializing Hyperloop technology. And then after a follow-up discussion with Dr. Arvind, it became very clear that bringing the expertise that we have in terms of design and fabrication and project management of the test track would be a way that we can help accelerate this next phase of the Hyperloop technology development in India. And what I'm very glad to see is that today the global Hyperloop conference that's going on in IIT Madras has brought together teams from all across the world. One of the very key and I think important parts of what is going on today, where you all are, is the fact that there is an ecosystem, not just the technological ecosystem or the startup ecosystem. It is an ecosystem that has included large-scale organizations, starting from the government of India. You have L&T, you have ANSYS, you have a whole host of different organizations who are contributing different aspects to the development of the Hyperloop technology. And you're combining not just competition, but you're combining competition and collaboration, which I think is a very, very critical aspect of what will take this technology forward. There are some very, very key drivers in India, and I think that makes India the right place for moving forward much faster than what we have seen elsewhere in terms of commercializing Hyperloop technology. Now, for sure, it's not a technology that will come in tomorrow. We know that there are many things that have to be solved. And in order to make sure that those are solved, we from ArcelorMittal are surely going to be with the development teams to see how we can bring our expertise to that part of the development that makes sense for us. One of the points that I think was very interesting for me and for ArcelorMittal was that the way the project is being conceived in India is to look not just at the end vision, but also to look at the interim solutions that will start to make sense from a business perspective. In all large projects with visions such as this one has, it's important to have good, clearly defined business cases that will make sense. And this is one of the reasons why ArcelorMittal was very, very interested in ensuring that we are able to support. We, ArcelorMittal, are coming into India in the last 3 years. We have a huge expansion plan that has been announced. While we have a 24 million steel plant plan in Hazira. So currently it's at 8.5 million, we'll take it to 24 million. We also have announced large expansion projects in the eastern part of India to be at roughly about 40 million tons of steel production. And this will be the core with which we can support the development of the entire infrastructure that will be necessary to commercialize Hyperloop. So with that, I will stop right now. I would like to congratulate the organizers. I would like to also thank all the companies that have supported this initiative, and certainly to the Government of India, which has been at the backbone of this initiative so far. Also, my best wishes to all the teams that are there from India and from abroad, some of whom we have worked together in the past also. And here's looking to success, and I hope that on my next visit to the campus, I will be able to see the test track in operation and successful trials being run with the help of all of you. So thank you again for the opportunity to share some thoughts and words here, and I wish you all the best.
Thank you, sir. we have our next speaker. We welcome Mr. Rohit Toshniwal, Director at Toshniwal Instruments, to come to the stage.
Good afternoon, everybody. I've been given a tougher job after L&T, after ArcelorMittal. I have to give a small brief about Toshniwal and how Toshniwal in this area of vacuum has been supporting the Hyperloop system with IIT. So we are a third generation organization specifically in the field of vacuum and vacuum systems. And that's the strength that we get. We cooperate with R&D institutes right from the inception idea until realization of what the institute really wants to achieve. We are a pan-India organization. Apart from India, we also operate in various parts of the world, and that's how we are able to support our partners around. Our facilities is not too far. Right in Chennai, we are a homegrown organization and take pride as the first few vacuum pump companies who were established in India. The area that we operate is right from space technology, R&D institutes, and today the upcoming market, which is Hyperloop. Vacuum could be as easy as a child drinking juice from a straw. Your lungs are actually the vacuum pumps that is pulling in the liquid into your body. Or it could be as complicated of launching a satellite into the space, or today's high-speed mobility of Hyperloop. The way we have been supporting the idea of IIT in the current project has been establishing simple systems, proving what they wanted to prove in this case, a small vacuum box where they probably put in, here in this case is a simple plastic bottle, and then they wanted to see how the product was going to react under vacuum, what's going to happen, what are the effects, so on and so forth. So reiterating that we start right from inception to reality. And I don't want to get into the kind of solutions or the pumps that we give, but vacuum as a science is not taught in any university. There is no degree for vacuum. There are no certificates for vacuum. Largely vacuum is just learned out of experience, and that's the experience that we impart to our partners around. That's how we started. We had the team from IIT visiting our factory, running through the ideas of what could be done, what could not be done. Feeling vacuum. Vacuum is just negative pressure. They were having some fun in the factory. And the theoretical concept was taught to them, and then came in reality to people who visited the site at IIT. Those are systems which has been given. IIT had a requirement to achieve an X amount of vacuum, and thereafter making sure that we were able to achieve it, seeing that the leak was all right, supporting the other partners, whether it was L&T or whether it was ArcelorMittal, for making sure that the necessary vacuum was achieved, because ultimately the system will be proven once you're receiving the necessary vacuum. And that was reality. We ran through the vacuum pumps, checking the leak at the 450 plus meters system, and this is just a live demo of what was from the concept to reality. I'm going to conclude with this, but together we grow, right from the old chariot days to fast-speed trains, the Hyperloop systems. Toshniwal will be always there to support anybody. Thank you.
Thank you, Mr. Rohit. Now I request our next speaker, Professor Pradeep Kumar, to come to the stage.
So good afternoon, everyone. So thank you so much, IIT Chennai, for inviting us for this conference. And as you have learned from the morning, that a lot of innovations, a lot of technological advancements are being done in the field of Hyperloop, and it will be a reality soon. We'll see this Hyperloop in the commercial way, maybe in a few years. I am representing Gati Shakti Vishwavidhyalaya. So basically, I'm a railway officer who retired. I'm retired in last year in June, and after retirement, I have joined this institute, Gati Shakti Vishwavidhyalaya. So Gati Shakti Vishwavidhyalaya is a central university which came into being, it's very young, so we came into being about 1.5 years ago with an act of parliament. And we are basically focused on the transportation sector, the whole of the transportation sector, including railways, roadways, airways, and also the waterways. So, you know, this national master plan was launched in October 2021, and this national logistics policy was launched in September 2022, under PM Gati Shakti. And the Gati Shakti Vishwavidhyalaya was created for the training and, producing the engineers who will be trained for the transportation sector. The needed talent and the specialized manpower to accelerate and sustain the growth momentum for the country. As I said, the GSV is a new university which is created in September 2022 by an act of the parliament. And the unique mandate for this university is to create the best-in-class resource pool for the entire transportation sector across the technology, management, and policy. The university follows a demand-driven curriculum. Basically, as per the need of the customers, we design our curriculum. Right now, we have only 763 students, 27 regular faculty, 4 distinguished visiting professors in their field. Our campus is Currently, we are sharing the facilities with the National Academy of Indian Railways, which is spread in 55 acres. And we are also now in the process of acquiring additional land for 110 acres where this new campus will come up. Right now, we have the programs related to BTech, BSc, BBA, and MBA. And we are going to introduce from this year the new courses for the MTech and the PhD. The vision of the university is mainly revolves around two words: innovation-led and industry-driven. So these are the two keywords which drive the vision for the university. We have two streams, School of Technology and School of Management. We also have a Center for Executive and Continuing Education, wherein our goal is to give the education to the working professionals. The university is funded by Ministry of Railways, and Shri Ashwini Vaishnav is our Chancellor, who is the Honorable Minister of Railways. We have Executive Council, wherein we have the people from different fields of the transportation. The four distinguished professors, Mr. Anup Malahoti, who is the former chairman and CEO of Railway Board, Mr. Pawan Kumar Agrawal, retired IAS officer who was a special secretary in logistics, Prabhuda Ganguly, who is in the field of IPR, and Satya Gupta, who is the president for the VLSI Society of India. Apart from this, we have a lot of visiting faculties who are expert in their field, including the railways. Right now, as a new university, we have started the courses in 5 streams of technology for the BTech, and we are giving specialization in the rail engineering. So our curriculum, about 20% of our curriculum is focused towards the courses which are related to the railway engineering. But in future, we are also going to start the courses in the aviation, BTech in aviation engineering from the next academic year onwards. We were not having any MTech courses, but from the next academic year, we are starting MTech in intelligent transport and MTech in railway engineering. These are for the working professionals. We have regular MBA courses in the logistics and supply chain management, also in ports and shipping logistics. And now we are starting 3 more courses for the MBA, which are again for the working professionals only: logistics and supply chain management, multimodal transport, and metro rail engineering in collaboration with the DMRC. Also, we are starting PhD programs in engineering and management from next year. So I will skip some of the slides for the paucity of the time. We have specific courses which we run for the railway engineering, which some of the courses are common to all the programs, like Introduction to the Rail System Engineering, Principles of Railway Operations, etc. And some are specific to the branch, like for the civil engineering, there will be railway technology, high-speed rail infrastructure systems, railway station and terminal designs, etc., etc. Since we are focusing on the transportation sector, so we provide internship to our students at 3 levels after first year, second year, and third year. So 2 to 3 weeks internship is there after first year, then 4 to 6 weeks after second year, and 6 to 8 weeks after the third year. GSV has done has entered into many memorandum of understanding with different organizations, which could be useful for the transportation sector and for the university to grow as well as for the industry. Like we have an MOU with the Airbus. We also have MOU with the Department of Promotion for Industry and Internal Trade. We had a workshop recently on 8th of April, wherein about 100 trainers from different centralized training institutes as well as from the state training institutes participated for the Gati Shakti Master Plan. We also have MOUs with the Kram Yogi Bharat, Nippon Koi, Delhi Metro Rail Corporation, Indian Maritime University, some of the topmost academic institutes like IIM Mumbai, IIT Gandhinagar, IIT Jodhpur. We had our first convocation last year. In fact, this university started, before this university started, there was National Rail Transport Institute, which came into being in 2017. And our first batch passed out last year, so we had our convocation this year, wherein about 380 students were awarded the degree. This is the new infrastructure which is coming up at Vadodara in the same campus. So the work has already started, and we believe that in next 2 to 3 years, we will have full-fledged infrastructure in place. So, as I said, we're starting few more courses in the coming from the next academic year, and we are also starting number of courses for the working professionals. So that's all about the university. This is the main palace where our university is working. Thank you so much.
Thank you, sir. Our next speaker will be through online. I welcome Mr. I welcome Mr. Mehmet Arjun, Deputy General Manager of
Okay. Wait.
Yes, Mr. Mehmet, it's on to you.
Not this one, sorry. I'll share.
Good morning, Mr. Mehmet.
Okay. Yes, it is Mehmet again. How are you? Am I on the screen or?
Yes, Mr. Mehmet, you're live. You may start now. Thank you.
Okay. Can I start?
Yes, sir, you can.
Okay. I don't see who are the audience, but I would like to say hello to everybody. I am Mehmet Örgen from Erciyes. I am the Erciyes Hyperloop Deputy General Manager. And I have been in this Hyperloop community since 2016. Almost 3 years after Elon Musk announced this concept. So I've been here with many hyper friends. Like we have a WhatsApp group we call Hyper Friends. So many friends in that hyper WhatsApp group. So you are also among our hyper friends. So actually I was planning to be physically there. But last week I was in Düsseldorf, and the agenda and schedule I got last week, and it wasn't possible for me to visit directly. So we decided to speak online, and I will tell about mainly when I speak in these types of events. Mainly I talk about all Hyperloop events all over the world, the developments, Europe, Canada, US, Turkey, but I know there are many speakers who already spoke, many experts, and who are very good hyper friends of mine. Mars Koize is there. I assume that Dennis, Gabriel, and some others, they already introduced their views and what's going on in Hyperloop environment. So I will mainly talk about what's happening in Turkish Hyperloop environment, what Erciyes is doing as lead Hyperloop developer in or Hyperloop promoter in Turkey. Actually, it's not the first time I've been talking. In 2023, I was invited by Indian Hyperloop Committee. So it was also a Zoom presentation, Zoom conference more than a year ago. So I am familiar with colleagues. Also, in the European Hyperloop weeks, I have met many of Indian Hyperloop teams. And you see, this is also a memory from the past. In 2022, my Avishkar, dear hyper friends, they have some Erciyes booklets, notebooks, and they are taking notes. I was just passing by. Okay, so shortly I will tell about Erciyes. Erciyes mainly steel pipe manufacturer, large diameter, spiral welded, mass producer of tubes, Hyperloop tubes now, but mainly water, oil, gas, and piling pipe manufacturer. And second business is railway business. We manufacture rail wagons, mainly freight wagons, and also we have logistic company. We have renewable energy investment, wind and solar, and we have also mobility branch. So when you combine all of these, actually, it is components of Hyperloop. You know, pipelines. We manufacture large diameter tubes. We are in the railway business. You see my cursor, right? The moving mouse. You see it? Okay, hopefully. And we also have energy investments and mobility. We combine it now with railway, the first and last mile transportation, and in the future, hopefully, Hyperloop will be mutually used by our mobility tools. So our main steel pipe business is we are doing business with more than 90 countries all over the world, and from US to Canada, even to the west of US and Canada, and Africa, and then South America, we export pipes. We manufacture pipes. So you see the diameters of manufacture, the pipes we manufactured. Lately, a water pipeline to 3.2 meters, and you see Hyperloop 4 meters that we will be manufacturing. So one of the fairs, I was pointing how large this Hyperloop tubes would be in some solutions. And we, as pipeline manufacturer, we also work on, besides Hyperloop tubes, hydrogen tubes. We are developing hydrogen tubes lately, and also not shown in this screen, but we also work on carbon storage, carbon carrying pipes. So in pipe business, we are not a regular pipe manufacturer. We are mainly bringing technology, innovation to pipe business. So we have a partner. Çimtaş is maybe some of you already heard when I present in my previous presentation. Our partners, another Turkish company. We are the mass producer, and Çimtaş will be providing the final details of the tubes, the flanges, stiffeners, and manholes, and some branch mounts. And as Erciyes, since 2016, we've been working with almost all Hyperloop companies. As you see, there was Hyperloop 1 here. I put this slide because some of our previous audience were asking what happened to Hyperloop 1, and Elon Musk was failed in this Hyperloop business. And as you know, Hyperloop 1 is only one of the leading Hyperloop developers. And now they decided to be out of this environment. So Hyperloop TT, Transport, Swissport, Zeleros, Nevomo, Hart, and Toom is doing a great job, and our Korean and Chinese friends also trying to develop. And also, I should also tell about a little bit how we started with Hyperloop business in 2016, 2017, when Hyperloop Transportation Technologies was trying to build their first 320 meters, 4-meter diameter test tunnel in Toulouse. We started to work and we developed together, but at the end, another company provided. But since then, we are partnering with Hyperloop TT. In 2022, we signed an agreement to manufacture 5-kilometer test track, but just after signing 10 days after that, this Ukrainian-Russian war broke out, and the Russian steel provider, we had this Russian steel provider. So it now stopped at that point, but our agreement is valid. Now it is Hyperloop TT is part of the consortium in Italy, 10 kilometers project, and it will be 50 kilometers hopefully. Beginning of this year, they signed feasibility and design agreement. So hopefully we would like to be manufacturer in this project. We also have very good relation with HART, my dear friend Mark Goize, and all HART teams and the European Hyperloop Center teams. Last 2 months ago, in an event in Turkey, we were invited by Hyperloop Development Program to be part of it. We signed an agreement and announced that now we are working with under Hyperloop Development Program. I will shortly tell about this Turkish Hyperloop competitions. After we started in 2016 and many projects trying to develop, and as LGS and by myself, we tried to increase awareness and make a new Hyperloop community in Turkey. It was successful, and the last 3 years we have Hyperloop development competitions in Turkey. So in these competitions, almost 40 universities are competing, and in the first one was 37 universities. And as I can tell you that almost 40 universities have their own Hyperloop development teams and developing their Hyperloop pod. And this is this 210 meters test track we built in Istanbul under our National Research Development Center. And the competitions we did here, we have but it is not a vacuum tunnel. As far as I know, you will have a vacuum compatible for 122 meters test track, which would be very benchmark in this community, and they're looking forward to the launch of this your test track. Hopefully, and I couldn't join this one, maybe the other one. I will show you a very short presentation. I'm not sure if this is the this is the test track and the research development center. Our teams are working on it. And yes, last 2 years we had these competitions, and this year will be the third one. And last year we had international participants. You see the tunnel here, and a short vacuum tunnel. If they pass the vacuum tunnel, then they go into the 210-meter tunnel. So at ministerial level and lately, maybe at the presidential level, there is interest on Hyperloop. So I just wanted to show you this very short video, 1-minute video, that it started 3 years ago, and hopefully you will have a bit better than this one. Okay, so this is our and I can show you this map. This is last year from Canada to Korea. We are trying. Myself and Erciyes, we are trying to develop both projects, both increase awareness and create the community. So I don't go into details, and most of them you are familiar. And last but not least, 2 months ago we established Erciyes Hyperloop Technology company, and now we will do. We are the infrastructure provider, but our vision is to be a Hyperloop developer, and this is the end of my 10 or 15 minutes presentation, and this is my contact info. Which questions if you have, please contact me and LinkedIn me. Okay, I think my presentation over. If any question or I'm not sure, no, I can't hear anything. Canan, is it okay?
Yes, sir. Thank you then. Thank you, sir.
Okay, so we are done, right?
Yes, sir.
Okay, thank you so much.
Thank you, sir. Thank you for joining with us. Now I welcome Mr. Rajesh Jain, Principal Executive Director at RDSO under the Ministry of Railway of Government of India. Please come to the stage.
मैं इससे बढ़ा दूंगा ठीक है सर Namaskar. Am I audible? I am Rajesh Kumar Jain, Principal Executive Director, Railway Board. I am looking after this subject from the ministry side as a nodal officer. So, because time is short, so basically a lot of people have already talked about RDS regarding Hyperloop. I will just touch upon how this concept has come and how it is already there in some form in railways. So if you see, the concept was basically, if you see in 1900, there is a Dr. Lethbridge. He's called father of linear induction motor. If you can see YouTube, you can find he has given that concept in 1900. And this concept, people tried. You can see his lecture series. He was professor at London Imperial College of London, and you can understand what is the basic concept. But at that time, it is basically, if you see on left hand side, is a rotary induction motor, and that side is linear induction motor. Basically, if you wound the coil in that format. And if you make a rotor as either as an infrastructure part or depending on the situation, then with a linear three-phase excitation, that thing can move. It will work as a linear induction motor. This is how it has come in railways. There are 16 subways where it is already in use. What we are telling means some of the, if you see in Japan, there are 4 or 5 subways, China 5-6 subways, and Canada 1 subway, 2 or 3 subways where linear induction motor is already in use since 1990 and working on 750 volt system. Here if you see that copper part, that is a linear induction motor, and infrastructure side there is a reaction plate, which is a rotary part. Advantage is it has no gears, and first of all it has no gears, it works on thrust, so you can put any power starting torque. If you have in the railway, typical railway system, whatever is the weight of the engine or vehicle, you cannot give more power at the starting because of friction limitation. Or when you move on a ground, if it is a slippery ground, you cannot walk because friction is necessary. This magnetic level, this linear induction motor works on a thrust principle. You can climb this thing, and this is a part of drive. If you see a Disneyland and all, basically it was part in an amusement park and all, but it is not popularized. So now it is becoming a concept which will be one of the ingredients of Hyperloop. So I will just not touch upon. The advantage is if you have linear induction motor, you must have seen Chennai, mammoth is infrastructure for the use of metro. If you see a metro limb, the infrastructure cost can be reduced because it has, if it is underground, then because the wheels will be required for only steering. So it can have low, just like a bus. You can put it in a tube and people can, this infrastructure which metro limb may use, or it is already using, it has a low floor. So it can easily amalgate with the road advantage, and you need not to have such a mammoth civil infrastructure. So, and secondly, the tunneling cost will reduce because wheels are very small, so it requires a less tunnel diameter. These are advantages. It can take any sharper curve, or like if you see a Delhi, you must have seen the Delhi, old Delhi. If you want to work as a feeder route, this linear induction motor based transportation system can go any zigzag curve because at low speed. These are some of the use cases where subways are already working. Then concept came maglev. From the Hyperloop, the concept came maglev. In maglev, what they have done is they have put that linear induction motor part on they have put the coils. So infrastructure has become very costly. So you need infrastructure full of copper, and so it has a limited success. And the use case is there from Shanghai airport to Pudong, and other 2-3 maglevs are working. One is in South Korea, one in Japan, and 2 in China also. These are the classical ingredient in case of maglev. So you need levitation also. So you must have seen, everybody knows now levitation and all, so I am not going in those details. The difference between 3 prominent maglev is regarding their propulsion system. Japan has used repulsive principle, Others have used attractive principle. This is how, basically, you must have seen a booster unit, those people who have gone. If you provide an Hyperloop booster unit, you can reduce the size of, on infrastructure, the power, on the pod, rather, not infrastructure, pod, you can reduce the power requirement or of linear induction motor. So you can have, for certain portion, you can have accelerator, just like Mablet. And I was very happy to see that students are working on, Chennai students are working on that. It's just like in a rifle, you give an initial velocity. Then in the cruise mode, you require power that can be done through linear induction motor. So then question came, whether Hyperloop is really going to happen or it will remain a pipe dream. And people thought Hyperloop will be just like whenever there is a pandemic, you can just throw the people. So this is a cartoon. So it is a pipe dream. So now it looks, and I am happy that 16th April 1853, India first train was run. And we could see after 3 or 4 days a trial run of by the sub-skill level by the IIT Chennai. I am extremely delighted. So next is how Hyperloop concept has come. That in 1930, Elon Musk gave the idea, but he has a different idea with air velocity. He thought of propulsion through air bearings and all. But now things are changing. So concept, some people have concept of giving power from overhead, or India is working from the bottom collections. So these are the key elements of Hyperloop. Levitation, propulsion. Levitation and propulsions are already demonstrated in maglev and subways. Pod is also there in the form of train, but it requires a certain guidance. The basic success of Hyperloop will be if infrastructure costs can be minimized. And in terms of maglev, Hyperloop aims for reducing the infrastructure cost. And the important thing which we have to look at is the safety standards. So that's why people started with the passenger, and now everybody is going that they will go with first with the freight. So that's why India is also thinking to try for first, so that you don't have much regulatory provisions for the safety. Once you prove that, you can go through for the passenger. I will not touch upon because these have been already in touch. These are the prominent people who have done some work on Hyperloop globally. And safety guidelines have been issued, and safety guidelines, I think, in Germany also have been issued. It's the same company. Basically, I'm just running through because text is more written, so I'm not going to those parts. So what is the strategy of Indian Railway? We have signed after Indian Railway has developed a trolley of this thing at Nasik, and after that they tried to engage with the IIT Chennai, because when we saw that IIT Chennai is already working, so we have a MOU with Chennai, and it was signed 2 years back, and and I think in July it will conclude. For laboratory subscale, for that we have given 8.53 crores. These are the points which has been agreed between MOU. Please share my presentation to everybody. After signing with this thing, our strategy is that you must have seen, we have come out with a consultancy also. The job of consultancy, which is likely to be, I think, closed by end of May, first week of May, sorry. There, what we are aiming is that they will make a strategy for India. How we should go, because there are technological challenges. And for that, one slide I have made script is there is already joint group already working on Hyperloop, JTC 20, I think, which is on a draft stage. So after detailed project report, we want to do a proof of concept on full scale, and that through academia and apart from the major players also. If major players are ready, we are ready to collaborate directly with them also, and secondly from indigenous through IIT. That is our aim. And we want to do 3 proof of concept in the area of LIM, MagLab and Hyperloop. So all 3 POCs will give thrust for, it will be a journey for second stepping stone. That is our rough idea, but let us see what our consultant gives us, what should be our roadmap. The important thing is there is a regulatory challenges. India has to frame a regulatory network to which ministry this will become and who will make the safety cases. That will come through Act of Parliament. And our vision is by 2030, we should have 100-kilometer Hyperloop working in India, POC by 27, and at least 2 corridors by 2047 when we will be celebrating 100 years of independence. So this is the roadmap. Thank you very much. Sorry, I am a bit fast. Please excuse me. Because my people have told that I have to finish by 7 or 8 minutes. I think I have done that. Thank you.
Thank you, sir. Now I request Mr. Shankar Raman, CEO of IITM Pravatak, to come to the stage.
So good afternoon or good evening, whatever is depending on your time zone. So who are we? What we do? We are a Section 8 company, which is basically a not-for-profit organization from IIT Madras. We are the technology innovation of IIT Madras. We are funded by the Department of Science and Technology. Our main, under something known as National Mission for Interdisciplinary Cyber-Physical Systems. Basically, we work in the area of sensors, networking, actuators, and control systems. And to give you briefly, these are the 4 target areas that we work on. One is technology development. We work on entrepreneurship development, human resource development, and international collaboration. And we are about 3 to 4 years old. And in each one of the areas, how we are different from other organizations is that we are looking at mostly patents instead of paper-based research. Okay, so we call this as the translational research. And We work in many areas. We have been funded by the Department of Science and Technology up to 170 crores for 5 years, and 1 year we lost in COVID. So we are working in the areas of healthcare, industrial automation, and cyber security is one of our areas, because any of the cyber physical systems, the major problem is security. The second problem that we are working on is in 5G and communication systems. We have a security test lab for 5G communications. We do the end-to-end testing. So what is of interest to you probably will be this part of it. We actually support entrepreneurs at 4 stages. One is entrepreneur in residence. When you do your graduation and you come up with an idea, we take you as entrepreneur in residence, and then we actually fund you every month, and also for some of the prototypes that you want to develop. This goes on for about a year. Then as a second stage, Prayas, here we look at making your POC, proof of concept, as a prototype. This goes for about 2 years. We fund you about 50 lakhs during this period. And at the end of this, we expect you to have some patents of your prototypes. The third stage, we ask you to start a company. We take some equity. We fund maximum of 50 lakhs. We take equity of 5%, and 1% goes to the IIT Madras incubation cell. And this is where we have been very successful. We have actually funded 35 companies in the past 4 years. 4 of them have got VC funding, 1 from Secure Capital. The company is MindGrow. In the 3rd floor, you can see that company. There are other companies which have done quite well. It's called Eon Space, SecureWeave. SecureWeave has a product that produces a kernel protector. There are only 2 companies. One is Linksworks from Israel, and SecureWeave is the next one. Likewise, we have about 35 companies working in various areas. We do a lot of other projects also. I mean, you can visit us and you can look at our website. We do a lot of work on healthcare. These are some of the startups that you can incubate it, and one you could see is Tutor. Okay, so there are other companies, as I told you, MindGrow, SecureWeave, is this company called 1 Megam, which works on 5G. And then there is this company called Music Temple. It basically converts your music into scripts. Western music has notes, but Indian music has nothing. So this company actually converts Carnatic, Arabic, or Hindustani music to scripts. And we have found quite a good use of it. They have got a patent. And the first usage that they have done, it's a very interesting problem. In Assam, for example, people have forgotten many of the folk songs. So what we have done is we are working on taking those folk songs and converting it into scripts and teaching it in schools so that the school kids can start singing those folk songs. So this is one application. There are other applications in military which I don't want to discuss. But what started as a fun seed funding company has led to something which we never thought about. So this is something we love about deep tech. Okay, and that's why we seed fund many of these deep tech companies. For deep tech companies, what do? You need manpower. So we work a lot on skill development. In fact, we have 3 programs. One is for, we have programs for school kids also, because at the end of the day, deep tech needs mathematics. And school kids hate mathematics because of the mathematics teachers. Okay, so for this, to overcome this problem of students avoiding mathematics teachers, we have something known as out-of-the-box thinking. It's open to anyone. Please register for the course. We only charge an examination fee. It has very interesting mathematical problems which you can try to solve at your age also for old people who are here. But for youngsters, it could be fun. So please try that. And once you finish that, you come to engineering college and you don't get a job. We have something known as a finishing school program. Probably IITians will start applying for it now. But this program actually includes, this program actually includes, what we do here is, we actually work with companies. For example, Sony, we work with Sony. And Sony has this computer graphics as one of its strong points. If you want, you can visit our lab. We have got something known as a spatial reality display, where you can have 3D, visualize 3D objects without wearing any glasses or anything. And the screen size is approximately this much. Okay, so this can be used for prototyping if you want to put your Hyperloop and see how it will look like, and you can try out all those things in our lab. So to get that kind of, so what we do is we join hands with these companies. Currently we are in talks with Airbus. So we join hands with these companies and then get the unique skills that they need, and then we train people for those kind of skills. For example, for graphics, we start right from mathematics, basics of numeric systems, and up to we teach them how to program in SRDs. This is a 6 months program, so we do it sort of internship kind of stuff. Then you can go to know about Digital Skills Academy. You can just go ahead and take a look at our website. This is how we develop this deep skill ecosystem. And these students are either placed within our startups. We open up some of these students for our startups, or they actually form a company. If they come across, they can become entrepreneurs, and they can. We do the seed funding and take it over. We also do a lot of projects of national importance. This is something very interesting that we do. There is something known as petroglyphs or geoglyphs in a place called Ratnagiri in Maharashtra. They have rock cuts which are about 10,000 BC. So we are doing documentation for them to make it as a World Heritage Site. We welcome you to visit this place. It's a slightly remote place. The good thing about this place is you can get good mangoes in the category called Alfonso. It's very famous for that. So, and Balagangadhar Tilak was jailed in that place. So these are two significant incidents in this. These are the petroglyphs that we are talking about. You will be surprised to see that they have rhinoceros and other things carved in Goa, Konkan, where you never see this. Today you believe that they are in Assam, but they are carved in Goa about 10,000 BC, which essentially tells you that these kind of animals were there, or people had migrated from Assam to that place. Please take a look at this. So I was talking about out-of-the-box thinking. I was talking about the finishing schools. And then as far as international collaboration is concerned, we work with Sri Lanka. We try to bring their startups to India. We try to provide market opportunities. So you'll be starting some of these startups coming to Research Park somewhere in May or June. We also work with Nepal. We also have started focusing on the Middle East. So this, we also do a lot of work. This Kalvi Shakti Rural Interaction Centers, the Honorable Prime Minister made a mention about this in Kashi Tamil Sangam speech. This is basically to ensure that rural kids get access to tuition kind of environment using virtual reality. So we are very proud to say that we have been able to increase the performance of students in Uttar Pradesh and Tamil Nadu, doubling their marks from 5th standard up to 12th standard. Okay, how we do it is we give them virtual reality kit, we conduct separate sessions for them, and they actually do experiments using virtual reality, because they don't have access to labs in rural remote areas. So that's it. Why we are part of sponsors, so they asked me to speak, and many people do not know about Pravartak. So if you have entrepreneurship urge, please apply through our website. It's open 365 days a year. We have quite a good amount of funding. We are looking at incubating at least 75 companies this financial year. But this should be in deep tech. Don't come back saying that I have a platform, can you fund me? Okay, it should be in deep tech, preferably with hardware and other components, not just software. Don't bring platforms. There are a lot of companies, VCs, who can fund software. Okay, thank you very much. I appreciate it.
Thank you, sir. Our next interaction will be through online. We'd like to welcome our chief guest for the day, Ms. Jaya Varma Sinha, Chairman and CEO of Railway Board of the Indian Railway. Good evening, ma'am.
Good evening. Can I be heard?
Yes, ma'am, you are audible. You can start your presentation, ma'am.
Right. Namaskar and a very good evening to all the esteemed guests, distinguished speakers, and fellow enthusiasts of transportation innovation. It is my privilege and honor to have this opportunity to address you all today at the Global Hyperloop Conference hosted by Indian Institute of Technology, Madras. As we gather here amidst the backdrop of cutting-edge research and visionary ideas, we are reminded of the transformative potential of Hyperloop technology. Hyperloop represents a paradigm shift in transportation, a leap forward towards a future where distance is no longer a barrier and speed is redefined. The scope of Hyperloop technology is vast and far-reaching, from reducing travel times between cities to unlocking economic opportunities and enhancing connectivity. Hyperloop has the power to reshape our world in profound ways. Imagine a network of Hyperloop tubes crisscrossing the country, seamlessly connecting urban centers, industrial hubs, and rural communities, facilitating movement of people and goods at unprecedented speeds. By introducing Hyperloop technology to people, it will require us to have a very strategic and an inclusive approach. We must engage with these stakeholders, foster public awareness, and address concerns surrounding safety, feasibility, accessibility, and even the cost. The best approach involves collaboration between governments, industry leaders, academic institutions, and the public to ensure that Hyperloop becomes a mode of transportation that benefits everyone. And I'm extremely glad that IIT Madras is taking a lead in this direction. And we are very, very proud and happy to be partnering IIT Madras to take us along the way where Hyperloop will not remain just in the realm of theory. Of course, the journey towards establishing Hyperloop technology is not without its challenges. From technological hurdles to regulatory complexities, we face a multitude of obstacles on the path to Hyperloop deployment. We must address concerns surrounding safety, reliability, and environmental impact, while also navigating legal and regulatory frameworks to handle the complexities of this revolutionary technology. Safety is paramount in our quest for Hyperloop implementation. We must develop rigorous safety standards, robust infrastructure, and comprehensive emergency protocols to ensure the well-being of passengers and the integrity of the system. Standardization will play a crucial role in this endeavor as we strive to establish uniform technical specifications and regulatory frameworks that facilitate interoperability and ensure global consistency. And this brings us to the importance of the Global Hyperloop Conference, which we are hosting in IIT Madras. I was going through the details of the program and it looks most interesting, and I'm sure it is generating a lot of interest and buzz amongst the participants. I am sure it will lead to many more new ideas and probable solutions to this challenging task ahead. This brings us to this platform, which is serving as a medium for collaboration, innovation, and knowledge exchange. It is a forum where experts from around the world come together to share insights, discuss challenges, and chart out course for the future of Hyperloop technology. By fostering dialogue and collaboration, we can accelerate a catalyst for innovation and progress, a forum where ideas are transformed into actions and partnerships are forged to drive the development of Hyperloop is not just a concept, but a reality. In conclusion, let us seize this opportunity to harness the transformative potential of Hyperloop technology to create a future where distance is no longer a barrier and speed is redefined. Together, let us embark on this journey with determination, collaboration, and a shared commitment to excellence. Thank you very much.
Thank you, ma'am.
Thank you.
Now I welcome our next speaker, Mr. Arpit Garg, the team head of Global Hyperloop Competition, to come to the stage and share a few words.
Thank you. Namaste, everyone. It's a great honor to host you all for the evening. We today have made a remarkable step towards the global development of the Hyperloop technologies. We are today under the same roof have gathered all the stakeholders, the academia, the startups, the student teams, and our backbone, the industries, and our policymakers. We thank all of you for all your support and blessings. We at GHC aims for the same, to foster an innovative society and culture of the Hyperloop technologies to simulate the innovations at much faster rate. We at IIT Madras have a very unique narrative of 3 C's. The concept building team, Avishkar Hyperloop, the commercialization team, Tutor, and the community building team, GHC, the Global Hyperloop Competition. Now, I would like to extend the invitation, and I believe that you all have gained some of the knowledge and gained a huge insights about the Hyperloop technologies. We at GHC ready to host you next year also for the Global Hyperloop competition, and I would like to have a special mention to our supporters, SE India, IITM Parivahan, and NSYS. I would like to thank each and every one of you. Thanks.
Thank you, Arpit. Now I request Mr. Vibhu Jain, Project Manager, Tayur Hyperloop Infrastructure Project, to come to the dais.
Yeah, so hello and good evening, everyone. I'm Vibhu Jain, and I would be explaining a bit about what the Hyperloop infrastructure which we're developing at IIT Madras is, and how it all started at IIT Madras through Avishkar Hyperloop and Tutor Hyperloop. So the concept of developing the world's longest Hyperloop testing facility and hosting a global Hyperloop competition started 5 to 6 years back by our professors and team heads. But the realization started 4 years back in 2021, where a bunch of 4 team members started researching on various different materials where we could have used to develop Hyperloop tubes. That could range from carbon fiber, glass fiber, coir, concrete, steel, and even waste material. But finally, we zeroed down our research to steel because of its impermeable properties, as well as it was already being used in many vacuum facilities which were available worldwide. But the only challenge which we identified was how to reduce the cost of the steel structure. Because currently, if you consider abroad countries or other competitors, the thickness of the tube is around 16 to 20 mm. And we wanted to reduce that cost by 1/3 margin. And hence we started rethinking on how we can reduce the cost, thereby reducing the material. So the first thing which we did while designing the tube is we took an inspiration from an airplane fuselage structure, which is basically a skeleton of formers and longerons on top of which a metal skin is rolled. That was the first inspiration. And second is, in a vacuum tube, which is meant for Hyperloop development, there are major two loads. First is the vacuum load, that is the atmospheric pressure which is acting on the skin. And the other one is the pod and track load. And we wanted to decouple these two loads in order to reduce the thickness of the skin required. And that's what we did. We realized and designed the tube in such a way that the track and pod loads completely go inside the ground through the pylons, and the skin is majorly responsible for taking vacuum loads. We designed a few prototypes, of which 2 of the testing videos are available here, where we conducted destructive testing. We basically buckled these 2 tubes at a particular pressure to validate our simulations at IIT Madras. And very happy to tell that our error was less than 5% in both of these testing which we conducted. After gaining feasibility as well as validation, we applied for patents as well for the vacuum tube and track. And that is when we are granted a patent, Indian patent on Hyperloop tube infrastructure, which is the vacuum tube, as well as magnetic track system for levitating vehicle. On the track part, when we were designing this track, we realized in the world, most of the teams are using an I-beam, which is not really the best suitable choice for the Hyperloop development because of its unstable nature, as well as the lack of integrating many different possible technologies like EMS, LSM, LIM, etc. That's when we designed this track where it could accommodate the linear induction motor, electromagnetic suspension, eddy current braking, as well as even the rotary motors for the propulsion of the vehicle. And that's how we designed the track. Now, I would like to call Praneeth to take up the whole process of how Avishkar was founded and taken up.
So, hi everyone, good evening. First of all, it's lovely and a dream to see a conference like this coming to reality. As they say, it's important for us to paint the future and pave our way through it, but equally be important and equally be mindful of our past, right? And I take a few minutes on throwing light on that. I'm Pranith, one of the co-founders of Galaxy Space, which is a space tech startup. My history is being a former team head and one of the early members of Team Avishkar Hyperloop. And I will take you through the building of a legacy, right? And for the lack of a better word, this is just what the team has done in the last 7 years. Right? And I don't have presentations filled with words and showing anything, but it's just a story. And the best way to put up stories are photos. Right, and this is how I'd start. So, cannot start without doing justice of putting this photo. So, the man you see here to the left is Suyash Singh. So, he graduated in 2019 with a master's from IIT Madras. He was the founder of Team Avishkar Hyperloop, and not exaggerating, but possibly the reason that we are all here gathered today. Right, so I would really request everyone in the audience to give a round of applause to Suyash. He was the man who back in 2017, sitting at his room in the Sindhu hostel at IIT Madras, realizing that Elon Musk had announced a competition for student teams to build Hyperloop, right? The SpaceX Hyperloop pod competition. So sitting in his room, he realized that, hey, we as a team at IIT Madras should be participating in a global competition like this, right? Unheard of this. There were no teams that were doing it. Hyperloop was not a technology that we were aware of, and definitely not something that we had reference papers for, right? It all started from a blank slate. Filling that blank slate was our first attempt. So fast forward to end of 2017, when we gathered a few engineers from IIT Madras. All of these faces that you see here were probably in their second years doing their BTech. All of us came together and built up our first iteration of building Hyperloop, right? Today, Hyperloop is a term that all of us know of very well, but back then we didn't. The only thing that kept us together was, hey, Elon is hosting a competition. We have a chance to meet him, we got to participate, right? That's what brought us together. What we did for that competition, built a 400 kg pod, added ultra capacitors and linear induction motors without knowing how each of these could work together. And as evident as it sounds, we qualified for a very preliminary design round because of feasibility, but doubled down on it, and we were thrashed out of the competition in our first year. Then we realized, okay, there was no chance of meeting Elon Musk. Avishkar was not a brand. This couldn't have been a resume point for students studying at IIT Madras, and half the team backed out. Then came in us getting a lot more engaged in CFI. So for all of our audience here, CFI, Center for Innovation, is a student lab with very much with a tagline, walk in with an idea, walk out with a product, right? And we started being a lot more active, started gathering students again, because there was the second attempt of our competition, which was the 2019 year. For the SpaceX Hyperloop Pod competition 2019, we gathered a team, and this time we scaled to a team of 60 people in saying, whatever it takes, we are going to make it to US, because the finals of the competition was to be held at the SpaceX headquarters in Hawthorne, Los Angeles. So our team came in together. We went through a lot of design iterations. Kudos to all of our sponsors, all of our advisors, industrial business advisors and whatnot. For a group of students in our second years, like when I joined the team, I was in my first year. And my second year of doing my bachelor's here, so I'm a graduate from IIT Madras. My second team, when we were building this, we qualified to the finals of the SpaceX Hyperloop competition among the top 22 teams. And we were the only team from Asia to have achieved that feat. That was not a journey that we took in a month, right? Or not even 2 months, but 3 months for sure. It didn't take us more than that, because that's all the time we had. So we had a lot of people question us, hey, are you even going to qualify to the finals, or just have a good design qualification? A lot of our professors at IIT Madras, a lot of our friends and family were like, you're doing a great job in attempting something very ambitious, right? But I'll tell you the specifics of what this involved. This time, we had brought down the pod from 400 kgs to 120 kgs. We were to build technologies, being second-year students, that even corporates like L&T today, thankfully, are here, but back then, Hyperloop was not a technology that companies focused on, right? And today, we have the largest of the brands like L&T, Arcelor, Toshniwal, and so much support, which back then didn't exist. We had to raise funds of 1 CR Indian rupees, $100,000. As a student team, back then, that was the largest funding that any student team had ever raised, right? What we achieved in those 3 months, doing justice with a brief 2-minute video of how we built India's first functional Hyperloop pod and what took us to the next step and eventually bringing us here today. challenges, understanding what customs look like, understanding what a lot of bureaucracy in import and export of electronics felt. So we went through that journey, assembled our own battery pack, and eventually built a pod together. Wires all over, which was something that even SpaceX engineers complained, but it's just the best we could do back then. So a lot of wires, a lot of assembly, sleepless nights, countless days. And eventually, what this took us was to actually running our pod. So a bunch of sponsors have gathered together. This is at 4 a.m. in the night rather, not in the morning. And that, you see, is actually India's first functional Hyperloop pod. We've had some attempts from a few other Asian countries, but that's what took us to SpaceX. And this photo, which we always look at with pride, having an Indian flag out there, attracting a lot of Indians, which brought us great pride as team members to be holding a flag like that and standing out there saying that we did it, and we're standing out here. Last two pictures. First, this photo still is our laptop wallpapers, right? That's how happy we feel about it, to have met the man himself out there. The team that made it happen, the SpaceX Hyperloop competition 2019, we finished among the top 10, and as the best debutant team out there, so as the first team, we were the best placed out there. And thereon, I think the rest is history, being invited to a lot of TEDx talks, having appreciations from Honorable Prime Minister, numerous iterations, a lot of spin-off startups. So Galaxy is one, Aerodome is another, and few more brewing. So the team teaches you not just building tech, but a lot of entrepreneurship, right? And today, celebrating it with the union government, a lot of you sitting out here, thank you so much, ladies and gentlemen, for showing interest in Hyperloop and looking forward to a great future.
Thank you, Praneeth. Now we have our next guest interaction in online. I welcome our next chief guest for the day, Padma Shri, Mr. Sridhar Vembu, the founder and CEO of Zoho Corporation, will be joining us soon.
Hello? Yeah.
Hi, sir. You're audible. You can start. Yes.
I can start?
1 minute, sir.
Yes, sir. You can start.
Okay. So I don't see the audience. I get to see them? Or? Yeah. So first of all, sorry I'm not able to make in person. I've been just got back from Trivandrum after hectic visits there, and then before that I had to be in Delhi. So I was not able to make it today physically. Just the timing didn't work, and I wish I could be there. But this is a great. This is exactly the type of thing that really excites me. This whole Hyperloop technology. And as I told the team that I am willing to set up a 0.5 kilometer or 1 kilometer test bed in our own farm here. And we actually have a large land parcel nearby too, where I want to set this up as a test bed to test all these so that we can validate. You need large test beds And I'm also excited about this as a potential for rural transport, where getting from village to village, all that, we can pare down the cost, we can offer something really cool. This could be revolutionize our whole rural transport. So I'm excited for all these reasons. And I would be very happy to be a test bed here. And the other thing that could be potential here is the in-campus transport. There's hundreds, maybe thousands of campuses, whether it's a university campus, college, company campus, factory campus, all that, where getting around from place to A to place B is a challenge. And different places, they resort to different things, your golf carts and buggies, all that. And this could be a really good, in other words, those types of options, even without getting into the public transport, you could get early markets in that type of private applications, as I call them. And so that could be a very good go-to-market strategy. And I would strongly suggest that as one of the areas to explore, where even our campus in Guduvanjeri, for example, I can imagine we have easily a kilometer of loops around. And getting around from one end of the campus to the other end is often a challenge under the hot sun. So we run these golf carts and all that, and it's not enough, never seems to be enough. So the personalized transport system on campus for these applications, and then universities, of course, IIT itself has a huge campus that you have to get around. So these can be explored, and corporations can be really good places where, for us, it would be not only a productivity gain to allow our employees to go around, but it's also a cool demo, seeing cutting edge technology. So you have to target those types of applications. That's what I would suggest as I'm putting my business hat on and thinking through this. And of course, a lot of technology needs to be validated, and it's exciting times for this. It's very early days of cloud or early days of AI, any of that. There's so many things need to be invented here. And that's the best time for an engineer, right? You get to invent stuff. So I sometimes I wish I were 25 again and trying these things now. And of course, I have built my own thing in compilers, all that now. But if I were 25, these are ideas I would want to work on. Hyperloop, drones. These are some of the technologies that I would be excited to work on. And the applications for solving our rural transport problem in a comprehensive way. And of course, urban too. But I am very partial to rural. So all of this needs to be solved. And I wish the organizers well. I hope a lot of ideas come out here and a lot of interesting innovations come. And I would love to visit and take a look. I just couldn't make it today. I'm sorry. And from a fundamental technology breakthrough point of view, I'll share with you some insights I have learned competing with the big guys in the West. There is indeed such a thing as frugal innovation. I have seen in our own industry, Zoho often has a smaller engineering team in India than our major competition would have in the West. And yet we are able to outcompete them. We are able to put out a better product than them. I have noticed it in many domains. And so this idea of frugal innovation, pioneered by the likes of ISRO in rockets and all of that, can be applied here. In other words, we don't have to be afraid that you are facing $1 billion funded competition. We can actually do an excellent job with small teams right here in India. That's something that personal experience I can speak to. We compete in the global markets, so our products are competitive. We win deals against global competition, yet often with R&D budgets that are a fraction of what is spent elsewhere. Of course, marketing budget is a fraction of that, but even R&D budget is small fraction, and smaller teams often, much smaller teams. So these are some of the ideas that I would like our young founders to keep in mind. In other words, think different. I mean, start from first principles. This is something Elon Musk often talks about. Think from foundations, think from first principles. You will often find better solutions, better, faster, cheaper, from any of these dimensions. This is true even in well-explored territory. I mean, take semiconductor design. That's a mature industry. Yet I've known from Indian silicon designers in India that we can often squeeze a lot more efficiencies out of these chips. Better chips, faster chips, all that. That Indian designs will be more efficient because we are applying that frugality, principle of frugality even there. A generation ago or 2 generations ago, the Japanese discovered the same ideas in automotive design, engines, all that. They were able to do smaller, more compact engines, which were capable of much better torque. A company like Honda pioneered these ideas. And the same kind of thing can be done here. And you would think automotive was mature even then. But Honda and then Toyota and all of them were able to come along and innovate a lot in that. So this is something that we need to internalize, that if we think from first principles, look at the problem with a fresh pair of eyes, we can often find better solutions. I am discovering the same truth right now in compiler design right now. I'm designing a compiler for a programming language. I'm discovering that there's a lot of things that we can do more efficiently than what has been done before. So we are filing patents and all that on those. So that's the same thing that I believe can be done here as well. Just not knowing the specifics here, I would still guess that there would be such opportunities if you take a fresh pair of eyes with people with no prior experience and therefore no prior constraints, because experience often constrains you. So that's really what I want, the message I want to give you. And I hope this is a great success. I hope to see some actual functioning designs and hope to see working prototypes. As I told this team, I want to come and I want to actually invest in this to as a prototype center in one of our campuses, one of our areas. So that I want to say thank you for inviting me here, and I wish I could be there in person. Thank you very much. Namaskar.
Thank you, sir. Thank you for joining us.
And I'll be happy to take some questions if there are any.
Is there any questions? Thank you, sir. Thank you so much.
Thank you.
Thank you.
Yeah.
Now I request Professor Satya Chakravarti to come to the dais and share a few words.
Good evening to all of you. I think there is one item that's actually standing between us and the stand-up comedy. And, well, this is not a stand-up comedy. And that is actually the most important item for which we are supposed to be here. And that is actually the announcement of the GHC competition. So to give you a sneak preview of what to expect in the next few to several minutes, I think the GHC team has probably made a very fantastic video that would announce the competition, but we will get to see it only when we have our director at IIT Madras coming here. So he's expected, I've been texting him, he's been in some day-long meetings, so he's expected to come here in the next 10 minutes. And I was also actually supposed to get some talk time here in this evening, so I was wondering if that's going to happen or not, because if the director comes, we would do the inauguration or the announcement, and then we will get on with the comedy. If not, then we have me. So that's the kind of, the balance that we have. Good. Now that I'm actually here, and if I were to get a little bit serious, we have been contemplating about the global Hyperloop competition for quite some time, ever since we thought we will be in a position to get the 400-meter track. So we used to refer to it as a 500-meter track, and so I mean, I'll do a little bit of comedy myself if I can. So the way the 500 actually became 400 is a little bit comical. So we wanted to actually find a straight section of tube to be laid in the new campus. There is a wall that is kind of like about 500 meter long, that's straight, and we said, let's actually now catch that area. Fortunately for us, that particular corner of the campus was not part of the campus's master plan at all. So for some reason, the architect of the master plan of the campus had not thought of doing anything to that particular corner. So which essentially means that no matter whatever is the master plan that they are going to do at this new campus, this area is actually going to be there, and we will actually be able to preserve this for posterity. So there are quite a few things that are happening that are kind of the first in the country or in the world in that campus. The campus is basically called the Discovery Campus. Those of you who have been there would have discovered how to get there in the first place. Sometimes it's actually a difficult thing because Google Maps actually takes you to some other place, and then you're led to discover how to get there. And then you get there, you can discover a few things. For example, I think we could probably say that the first semi-cryo engine test, or the first fully 3D printed rocket engine test, happened in that particular place by Agnikul. So if Agnikul dismantles and then goes away somewhere, we will still want to actually have a plaque there that said that this is actually where India's first semi-cryo rocket engine was fired. This is where the world's first 3D printed rocket engine was fired, and so on. And similarly, we would like to actually keep what is now the 400+ meter track over there for posterity. Even if it becomes of museum value, right? We would like to actually keep it there, is because it can be there. I think there is nothing that's coming up as far as that corner of that campus is concerned. But we were supposed to do 500 meters. In fact, many times we are sort of hounded by the railway saying, I gave you money for 500 meters, but you're not doing 500 meters, right? So we now have a problem that, is it per kilometer basis is what we had actually proposed, or whatever it is. The reason is we got 500 meters, but the last 50 meters ran into a lake, and we knew that only after the rains. So then we had to kind of cut it short and then say, well, we can't actually, it's kind of going to be difficult for us to run a Hyperloop tube on a lake, particularly at the end. I mean, as it is, you imagine that the pod actually goes all the way somewhere near the second half of the tube, and you're supposed to brake. And what if it doesn't really brake? It actually goes and hits the end, and we expect that the end will be closed because it should be under the vacuum. But if it's actually going so fast that it actually gets out of the door, we don't want it to further actually submerge into a lake. So these are the problems that we foresee. Therefore, we said that let's actually be a bit safe and keep it less than 450. We have got it around 410, and then we are expecting to actually do 422 because Mars is actually doing 420. We wanted to just be 2 meters over him, right? This is typically how this game is played, right? Yeah. So you see how globally competitive we are, right? We want to get that last 2 meters because somebody else is doing this, right? So we've now got land on either side, and we are actually trying to get this 422 through the summer, and fortunately for us, the elections happened, so That means the railway, we don't know who the railway minister is going to be, and we will wait for that to happen, and therefore we can actually wait for the inauguration to happen and so on. So it's been like a fortunate summer for us in that sense. L&T has been really sweating it out in the hot sun, trying to finish as much as they can, as quickly as they can. And they have been extremely cooperative with us, with students particularly. Think about it, right? L&T on the one hand, working with students here, right? The drawings sometimes don't match, and then in the middle of the night they have to figure out how to actually get the nuts and bolts connected, and so on. And this is vacuum. So there is, Toshni wall actually comes with their vacuum pumps, and then they want to test it out, and then we've been very fortunate, right? 300 meters worth of length has actually been achieved with a very, very decent leak rate that can hold vacuum. That's been tested. So what now? We had been thinking about this. We have been discussing this for a very long time. And we now want to democratize Hyperloop technology. That's essentially what this is all about. Which means we want to involve as many college students as possible around the world, utilizing this opportunity of having this 422-meter tube for doing several levels of things. It's not as if like every college can imagine that they will put a pod together that will run in this 422-meter tube. For us to be able to get a pod on the tube will require several checks to be done as part of the competition in the first place. So any competition team that's going to get their pod into the tube is actually a winner right then. And then we will have to have the competition among those teams that get their pod inside the tube. But in the run-up to that, there is like lots of technology layers that we will have to go through in order to get there. And we would like as many college competition teams to participate in those several layers, even if they are not exactly explicitly participating in getting their pod into the tube. There could be lots of competition levels that we set up where even bringing the pod is not part of the competition. First of all, you could essentially develop policy papers, position papers, route maps, and station designs. There are so many things that are outside of the tube and the pod that Hyperloop teams can participate. And suddenly you will now have a whole bunch of competition teams in India as well as abroad that can now jump in and come together, as we now have a flavor of in this particular conference itself, where everybody is now, this entire generation is actually thinking Hyperloop. And that's very interesting because that's kind of cut off from the next generation. The next generation is, or next generation as in the older generation. The older generation is not used to thinking of Hyperloop at all when they were in college or later, right, in their careers. And all of a sudden, they actually look down to the younger teams, and then they are actually mentally occupied with this thing called Hyperloop. And everybody then goes crazy saying, what's my son and daughter up to? Is there something wrong with them? And what's this education all about? And so on. That's the kind of maniacal, effect that we would like to create with college students. And let them come with designs, let them come and compete, let them prevail. We had the Pravartak CEO announce that he wants to actually incubate up to about 75 deep tech startups. So he was basically saying, yeah, let the competition teams come, we will incubate. We are like, wait, we have our own team, can you incubate? Right? So we have this competition right at home, and then for the competition as well as for getting incubated and so on. So that's a very healthy competition. We are setting up the competition in which we would want to participate. So how do we do this? How do we do this in a way that is actually not biased, right? So you can't have the competitor run the competition. And that's where we were actually very fortunate to have SAE India come on board. SAE India, again, for those of us who know, SAE India is actually pioneered in running automotive competitions around colleges. It's extremely popular among college students. And in fact, it is so popular, it's so diverse, it's so broad-based, it has so much participation around the country that the rest of the SAE outside of India actually has wanting to be emulating this. Because SAE is actually an international organization, it's Society for Automotive Engineers. And the rest of the SAE has been looking at SAE India, looking up to them to say, hey, how do you actually do this at some scale, like what you have done? That's exactly what India is all about. India today is not just about the tech talent that we have, but also trying to demonstrate the tech talent at scale. And that's what we are trying to do at Hyperloop. Thanks to them, we would like to actually bring them on board to actually set the rules, issue the rule book, and go with executing the entire competition. We can actually be just organizers, supporting the logistics for the teams to come and go, but we actually can be away from it and say, hey, Pravartak actually supported this, SAI India is running it, we just have student volunteers that are essentially organizing the whole logistics of how people will come in and go, get the judges here and the competitors here, get the stay done, all of that stuff, right? So this is the election season, so it's kind of like, for most of us, for most of the time, we think that Election Commission of India is actually part of the government of India, but not during election time. So SAA India will suddenly become Election Commission of India during the competition. So it's a great analogy at this time, right? So we think that that's actually how this is going to pan out. And we are looking forward to a large number of participation. We already have competing teams from abroad as well as India signing up to this by now. In the run-up to this competition, we will have several online events. We will have design challenges thrown in. We will have policy document challenges thrown in, and so on. We could even have humanities department students participate. So we want to actually try to make it as inclusively as possible so that as many student teams can participate at different levels. And finally, the climax of this will be the people who bring in their pod and get their pod to be selected to actually run in the tube and get them on the tube and actually run in the tube to find out who is the final winner. And we expect that we will essentially be in a position to showcase this in this part of the world and have a mark of leadership in Hyperloop, global Hyperloop technology, which essentially will feed into what the railways is thinking in this country on how what kind of technology should grow out of this to be adopted at full scale, and we then can try to get commercial teams then try to compete for full-scale deployment of these. And there again, I think, as I said in the morning, we have the Hyperloop sphere that is now getting emerged out of IIT Madras, which is the proof of concept technology development from Avishkar. We had some of us get to see that yesterday, last evening, where again, unfortunately, you had to put up with some of my speech there as well. And then we have the tutor Hyperloop that's trying to take it up at a larger scale, and we have the Parivahan Global Hyperloop Conference that is just about waiting to do the inauguration of or the announcement of the Global Hyperloop competition, right? Do we do that? Okay, what is he starting? Another 5 minutes. Say like 10 minutes. Maybe 5 minutes we start from this way. Okay, if it comes. So we all love our director so well, so we will just put ourselves to test. He has just started from there, so he's going to be here in 5 minutes. Let's just wait for 5 minutes. I think that's reasonable courtesy that we can extend to him. All through the day, I think we have been running late for a few to several hours. We have caught up a lot, right? Just to keep about 10 to 15 minutes delay, which is like, let's say, doing the announcement at 6:15 instead of 6 o'clock is not such a bad deal to wait for our director. Let's just do that.
Thank you all for your patience. I request everybody to remain seated. Now I request Professor Kamagoti, the Director of IIT Madras, to share a few words and announce the Global Hyperloop competition. Thank you.
Hello. Friends, a very good evening. I hope you had a wonderful day today. I am extremely pleased to announce the Global Hyperloop competition. The first of its kind in Asia, and we are bringing it to India in our Tayur campus. The competition will be held in the first quarter of 2025. The testbed will be ready. We are also planning a lot of very interesting things there. We will be giving a digital twin of the testbed so that people can experiment by simulation before they come here so that they don't have any surprises. It will be a very transparent challenge where and it will be also a very high-end challenge. All the evaluation parameters, everything will be made very transparent. And I'm sure this is going to be a very rewarding thing for anybody who participates, leave alone they win this competition. We want to set benchmarks. And this particular, post that competition, that infrastructure will become a very novel test bed for any startup who wants to experiment, develop technologies, commercialize technologies on the Hyperloop test bed. So this will be our contribution from IIT Madras. IITM for all. So this test bed will be for all. With these few words, I'm very happy to show you the inaugural video of this particular conference. So let us all view the first promo video for this competition. Namaste from India. I am Kamakoti, Director, Indian Institute of Technology, Madras. The competition will be conducted in world's longest student-maintained test track of 422 meters.
We are able to actually develop a full-fledged vacuum tube track for Hyperloop that allows students to come in and test their entire stack of Hyperloop technologies. This will actually spawn a significant amount of technology development from across the globe that will lead to the standardization of all these technologies.
One of the most unique things of this competition is from inception to completion, everything is managed by students. Even the track and the tube have also been designed by the students.
We invite students from all over the world to come over here and make use of the facilities that we have and make Hyperloop a huge success in the world.
Looking forward to meeting you all in Parivahan 2025. So friends, innovate, conquer, innovate, compete and conquer. This is the spirit. So welcome you, advance welcome to all of you to the Hyperloop Challenge 2025. Thank you very much.
Thank you, sir. And that's bring us to the end of our eventual day. I extend my heartfelt thanks to all the speakers, the delegates, guests and participants for this event. Thank you and have a wonderful evening. I request the volunteers to guide our delegates to the refreshment point. As you're all waiting, we have our next session is the entertainment session. We have few terms to be disclosed. Whoever going to be inside the premises, request not to use your mobile phone during the session. If you want to take any pictures, please take at the beginning. After that, please don't use your mobile phone. No flash, no photograph, no videograph. I request everybody to follow this instruction because this was personally given by the guest.